Okay, now we have a new microphone. So I think it will be even clearer now. So you'll be using a new microphone now. Let me check. The microphone's still the same configuration, I hope. Yep, BYCM1. Okay. Alright. you? All good?
Yeah. Thank you.
Alright, bro. The laptop, right? Yeah. Just place it over. This one, the one that doesn't work. This one also maybe need to check. So in Foxconn time itself didn't work. Yeah. Then I took it and put it in my bag, and now I put it in my bag. So yeah.
Bought online is not a real one. It's another type of PLC. It's all try to copy like and I ordered one this, but it's another model. Means this 8071, right?
Yeah.
The new one is 8072.
Oh, I didn't know.
No. Yeah, I bought, but on the way.
How much?
600 plus.
Oh, okay.
This
This one.
I find this because of the internet. From others. I'm not sure whether good or not.
This one can run on Jinx Boost 2.
Yeah, dimension 2. That means 3 cannot.
I think so because it's the FX5U. Jinx Boost 3 FX5.
Okay.
But that one.
And this one, I bought this with another edition. The new one, they say no more 71. They come out with 72. It's 553. Bring it.
Wintech.
Wintech, yes. Then,
Have you received or yet?
yeah, received, but all in IMD. But after convert, I can see from here, but the receipt is in IMD.
Ah. 8072.
2. I.
8072 or 8102? 8072.
No, 8072. Yeah, 8072.
Okay.
Because I bought direct from China, there is another app asset.
Yeah.
About.
Yeah, tahu ya.
Yes. This one in ringgit is 256.
Malaysian.
Yes.
That one I know cheaper.
only this model with internet.
Internet.
The others model no.
Yeah, some model have, some model don't have. But the smallest one is this one lah with the
Yes. Actually, I try to get bigger, maybe 10 inch, but without internet.
10-inch one, you need to go to 8071i or 8102.
A102. Another model.
Another model. That one is a 10-inch.
But with internet.
Yes.
Mm.
But recently I buy for one project.
Mm.
But I buy from here lah. How much? 2000 plus.
So the 10
Eh,
inch.
1800 or something. 10-inch. Okay, that one later we can test. You can go up. Test because I think your laptop I installed the
Yes.
JSOS 2 also, right?
Yes.
Okay. So you remember how to do a backup first?
Backup.
Yes.
PLC now is error. Do I need to restart?
No, 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 no. The Ethernet cable is. The Ethernet cable is connected. Alright.
No.
Doesn't make sense to me the JD one. They sent me.
Oh, this. They send with you, right?
I think the HR.
Oh. Yeah, I did early morning. I said that I know because I didn't receive the email. When they sent?
Yesterday I thought they already CC to you. I thought after you sent only I just mentioned notice they didn't CC to you.
Oh, okay, okay.
Yesterday I think they sent.
I can't remember the email, but I will just reply to them with that cable.
Yeah, we have received.
This one, the Petronas one, you just check lah.
Yeah.
Is that, I don't know about the bank account document that approve I signed already. Is it the review and the one also I need to sign or what? I don't know. Maybe review, maybe you need to sign and approval, maybe the owner need to sign or something like that. I'm just the manager.
Okay, okay. Yeah.
Start already.
Okay. Equals first. Okay, go to online. Read from PLC. FX5U. FX5, yes. Okay. Take this one, direct setting. In. Yes. Ethernet. Okay. Choose your laptop Ethernet. Yeah. Click here. Choose. Yes. Communication test. Okay. Connected. Then click OK. Now select all and backup. Okay, yes. Okay, go to main. Here. Main is open. Okay, program one. Yes. This is the program that they use, right?
Yes.
Yeah. So addition, subtract, double, right? Okay. Save first. D3 backup. go to project new. So you create a new project, yeah. Day 3, lesson 1.
Oh, day 3.
Create new one, yeah. You okay? You save this. Okay. Day 3, lesson 1. Okay?
Yes.
Right, so now what we do, okay, continue from the layer. Okay, these functions, okay? Okay. So we do again the match function, okay? So you put normally open, okay, SM400.
SM4.
Okay, you know that SM400? They're always on. No, that day we use SM400. Okay, okay, SM400 is this memory, it's always on.
0401 is always off.
Yes.
Yes.
Okay. Then you can add ADD.
ABD.
Yeah. ADD, okay, space. Like this one, you can use D0, D1, D2. D0, this is not 0.
Okay.
Then you add another one here. Control down. Okay, subtract SUB. Yeah, space. D3, D4, D5. Okay. Then you add control down. No. Okay. So let's say if the value is bigger, right?
Yes.
So we can use DADD.
Yes.
Okay, DADD. Space. Okay. So DADD is a 32-bit.
Yes.
So must use
2.
2, right? So D6, D8, D10. Yes.
Yes.
Okay. Then
Now.
yeah, we add all. Then we can test all the okay. Okay. Another one is okay, multiply. Okay, multiply. Space. So this is just a multiply, right? So D12, D13, D14. Okay, so you see, like the day you see, right? So for multiply is 16-bit, 16-bit, and 32-bit, right? Because the multiply value is bigger.
Yes.
Okay, so divide the same. You add a divide. So D15 can use, so D16, 17, 18. D. Okay. convert. Convert, save. Okay, download. Okay, where to download? Online. Right, PLC. Go back. Yes.
Sorry.
Dragging.
Pure water，OK，pure water 是你要去一个叫做，我想一下，在你的电脑那边，我想一下那个 screen 是什么我想看，它是我就是想不到你那个 screen 是什么 screen，一个大 screen，然后一个 pure water。你去那边可以看看，然后有个四方个白色的有写字的小小个，在你的大概，怎么讲呢？配上在中间双起来，你在大概在起点的地方，它写什么？你按上去看看。然后你第一个方面那个清单要念，好像写到7095还是什么，是吧？我没记错了，好像是吧？第一张清单，不过没有按你记得了。它总共3个嘛，1、2、3嘛，排就这样嘛，看得出来。还是你拍一张照给我点给你看，好不好？OK。 Yes, sir.
Okay.
Yeah.
Right.
Call from the company, someone who know how to operate the.
Now. Okay.
Yeah.
Then. Okay. Go to online. Monitor. Monitor. Okay. Same. Go to online. Watch. Register to watch. Watch window 1. Okay, this one can close. Element can close. Okay, you make it bigger, yeah. Some more. Yeah. Okay, I want format. Yeah. Okay. So you add all these D0, D1, D2. Here. You can add here D0.
How do you?
Yeah, enter. Okay, then D1, D2. Okay, then you right click here. Right click. Start watching. Okay, so you can keep any value. So if I keep add some values here.
2000 in 2000.
You can put any value. Just try to put some values and see what you can see. Okay, good.
Yes.
Can get the value. So, but it's not getting value, correct?
Yes.
Okay, so if you want to do that, we have to use this.
Yeah.
Okay, same thing. So you key in all these and test the values.
Okay.
Okay, for subtract, why is not showing? Oh, okay, because it's small. The area is small. You make it because you make it smaller, right? The value is that is correct.
How to make it in?
No, this one you can close first navigation, then you can open later. Correct, close. Just now we make it smaller, right? D4, D6, D10, you need to change here. Move to the right. Need to change to double word. Which one is double word? Need to change to double word.
Okay.
Then only we get the value.
Then.
So maybe what you can do, this value, right, make it smaller.
Small.
This value, this line.
Okay.
Okay, yes. Okay, so easy to change. No, just double click you can change. So my D40 also double word. Yes. Okay, good. Okay, so for divide, how to use? Because like I said, right, divide also too big.
Words.
And so it got two words, huh?
Yeah.
So D19. So you can the D18, you can change to double word. Must go to the D19. Go to D19. No.
Maybe I need to key a D90.
Yes, D19. Yes. So you see this one, like multiply is 16 bit, multiply 16 bit, go into 32 bit. Okay. Okay. Why need 32 bit? Because you see, 16 bit, right? Okay. What is the range? 32,000, right? Maximum. So if you multiply 32,000, multiply 32,000, you will get 1 billion. 1 billion something lah. So 32 bit is negative 2 billion, positive 2 billion. So can keep the value. Okay. And here. Yeah. Divide is 16 divide 16, 16, then 16 also. So the divide value here will be the balance. So you put 50,000, 5,000 divide 3,
Yes.
it means this is the divide value.
Yes.
Then I have balance 2.
Yes.
Okay, okay. So that's how it works. Any question?
Just now I tried to figure 5. Over the 5, then the thing not accept already, because the figure is too big. Let's say 2,000, 20,000 become 200,000, then the last zero, the thing not captured.
Okay.
Is it because of the out of the range?
Which one?
Let's say now I able to key in, let's say 20,000. I try 200,000, then cannot because the figure too big.
One is figure too big, and why cannot? Because it's a word. So word means 16 bit, right?
Yes.
16 bit means this is the range you can key in. Okay,
That
you try to key in.
means maximum I can key in say 32768 9. Then 9 cannot.
Yeah. You try and see. So the positive value is 32767. So that is the maximum.
32767.
Enter. Okay, can, right?
Yes.
Okay. Now try to key in 32768. Yeah.
Is it possible for me to make it bigger, like 16 bit become 32 bit because I want to key something there?
Yeah, then we have to use this one. Double ADD. So this D6 now at the D6 you key in 40,000. D6 because you haven't choose to I haven't changed to double wood.
Yes.
Haven't changed to double wood yet.
Yeah. So from D6, D8 and D10 all must change to double word, right? sir?
Yeah.
Okay. Okay, that's good. Is there any D sub, D multi, D divide?
Yes.
Can also.
Yes, can also. Want to try? You can try. You can try. You go offline. You go to edit. 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 Ladder edit mode. No, you click here first. Okay, now you. So at this side, this ladder edit mode. Same. Go to edit. Edit. Ladder edit mode. Right. Okay. So you want to add, want to try the D multiply, D divide. Okay. Because why? I want you to try this one. So here we can learn two things. Okay. Okay. Actually, three things lah. Of course lah, the max function lah. Okay. That is number one. Okay. Number two is we know when to use double load, when to use word.
Yes.
Okay. That is number two. Number three is if we use word. Okay. What is how the addressing? So this one is word, right?
Yes.
So just skip one enough. If double word, so I have to skip two. So we learn three things
Yes.
here. So normally all the training I will try to use this mathematical function because even though it's just a calculation, but you can learn the other. One is the addressing, so how to use the address. Another one is the data type. So whether it's word or double word. There's another one called real. Okay, we tried that one also. Okay, you add one more line, control down. So later you want to try the D multiply, D divide, can okay. Now this divide, you don't get decimal point number, correct?
Yes.
Okay. Now what we do, if I want a decimal point number, it's a DE, yeah, Denmark, England, divide. Divide. Yeah, DIV. Yes. Enter. You see floating point division, right?
Yes.
Okay.
Divide.
Okay. Clear? Okay. No.
Huh?
Must key all these three. Right?
Oh, sorry.
Never mind. Just double click. Okay. So DE divide is similar like the DADD. Means it's a 32 bit, 32 bit, 32 bit. So D18 already used ready. So D18 and D19, right?
We'll start from
20, 22, 24. You must use float.
Three also for.
Yes, must be float. It's not double load. Yes.
Okay. Good.
Yes. You try to download. Try to compile, download. Okay, monitor, then
Sorry, sir, I accidentally take away the D20.
never mind, you can put down that D20. No problem.
Saying there is no way to insert back there.
Ah, yeah, because you already deleted. If no, we can undo actually.
Okay.
Monitor. Do you monitor first? Online. Monitor. And 1 minute. You click it. Okay, now go to online monitor. Yes. Monitor mode. Okay, then you must right click here. Watching. Okay, now you key in the yep.
Let's say 5,000. Same as 5,003.
Yes. 163. Yeah. So just now is 1666. Then the balance is 2. Yes. It will keep on going. The number 166666. Okay, want to try the D multiply, D divide, also can. D add.
The float only for device only, right?
No,
But
for DE. For DE divide. If you see DE means it's a real number, floating point.
is there any DE and DE sub?
Yes,
Huh?
yes, you can try. For all. So for all addition, addition, right?
Yeah.
Addition, subtract, multiply, divide. So all this is a 16 bit, right?
Yes.
So if you want 32 bit is DADD, D
double,
sub,
yes.
D multiply, D divide.
Yes.
That is all 32.
Yes.
Okay. If you want floating point,
Yes.
then is a DE add, DE sub, DE multiply, DE divide.
But DE is for the decimal point.
Yes.
But how add and sub also can
Can.
be
Here. Why not? Okay, like this. For example, so let's say I have one program something. So DE divide, okay. Let's say from D10 divide D12 D14 okay. Right?
Yes.
Then I have another divide also. D20, D22, D24. Okay? Okay. So means this one from one calculation, this one another calculation.
Yes.
Now I want to add both of these. Want to add this up. But now you need to understand that this is real, right? The floating.
Yes.
Floating we call real.
Yes.
So this one is also real. So now I want to calculate. So I want to add these two values. So I must use DE add. That is the value of D14 plus D24 or maybe the result is D30.
I need to add those with the decimal point. So
Yes.
I need to use this.
Same goes for if you want to add with if you want to subtract the decimal points, then DE sub.
Understand. Then sir, what is the meaning of real here? Real actually
Real means
is the,
floating point.
yeah, the number already come out. Why we need to mention the real? Is there any other reason?
No, this is the data format. The data type we call real. Because okay, we have 16B, 32B, all that, right?
Yes, correct.
Okay, so all that we call data, the data types, okay?
Okay.
So
Maybe from data come to become the real or something like that.
no, okay. So actually got so we have one bit, right?
Yes.
Is a boolean, correct?
Yes.
Okay. Then we have 8 bit is a byte. Okay. Then we have a 16-bit. This is a word, or we call it as a integer. Okay. Okay. So integer, this integer don't have decimal point number.
Okay.
This like 32,000 to 32,000 or
Okay.
0 to 65,000. Okay. Okay, maybe I can erase this one or
Yes.
okay. And I can do a proper one. So you understand why I need to use real and okay. Now you see so 1 bit means we have boolean actually we call it like this. Oh yeah, okay. 1 bit is boolean now. So that is 0 or 1, correct? The value is 0 to 1. Okay. Then we have 8 bit, which is byte. Okay. Or we call short integer. Okay. So the byte means normally will be positive value only. This one can be negative 1 to positive 1 to 7. Okay. Then can be both also can lah. Okay. Then we have 16 bit. 16 bit we call it as a word and also integer. Okay. So this one can be both, means actually both lah. Okay. So means so can be 0 to 65535 or negative 32,768 to positive 32,767. It depends on what you choose here. Word sign, word unsigned. Okay. Okay. Now this is right, word sign, right? You try to key 40,000. Yeah. Enter. Yeah, right. Okay, but you choose here, you go to word, double click. You use the first one, word unsigned. Yes. Okay. Now you key 40,000. Can. So means sign means negative, positive sign. But the value can be negative and positive.
Okay.
Unsigned means just the positive value. So just the positive value is this one.
Is it just the positive or just the negative? No, just the negative.
No, don't have.
Just positive.
Positive value or negative positive. What sign lah? Sign means
So which both? One
Yeah.
is that one side, one is both sides.
Yes. Okay.
Okay.
But we need to understand what type of calculation we are using, because normally our calculation will be is a sign. It's not unsigned lah. All will be like not. So that's why we try to keep these numbers. Okay. Then so these are the numbers, maximum number we can key in. So these are the maximum number that word can keep. Okay. So Mitsubishi they call word lah. Okay. Some PLC if you see they call integers. So that's why I put both. Both is same. Okay. Then 32-bit we call it double word or double integer. Okay. So it can be 0 to 4 billion. The number, if unsigned, if signed means negative 2.1 billion to positive 2.1 billion. Okay, so that big number. So means so whether I want to use normal addition or double addition is depend on how big is the value. Now, so all these don't have decimal point number. Okay, all these. Okay, if you want decimal point number, so that one also is a 32-bit. Okay, it's the the size lah. The size is 32 bit. Okay, so we call it real. Okay, or the format, the data type, you can call it as the floating point. So we call float. Okay, so this one, the value is very big. The value is negative 3.4 times 10 to the power of 38. Very big. Okay, so but we don't get this lah until positive 3.4 times to the power of 38. So, but we don't get this means even 0.1 the value then must use real. So it depends on what type of value I get. Even just a small number, this one not because okay, this one very rare we use the right big byte, right? Okay, the byte very rare we use the byte. Okay, so mostly we use a boolean lah. Of course, our normal normally open, normally close. Then we have a 16-bit, 32-bit. Okay, so the depend on the values, small values, big values lah. If just one decimal point, then I will use this. Even though it's just 35.5. Actually 35 this one enough, even this one enough.
Yes.
But since I have a decimal point number, I will use this.
So means if the reading, the result come with decimal point, we name it real.
Yeah, we must use real, yes. So like this lah, for example just now, right? This divide, correct?
Yes.
Okay, so we try to divide, we get some value, but it's not in decimal.
Yes.
Okay, but that one also can accept, but I want decimal point number, so I cannot use this calculation really, so I have to use this calculation. Okay, yeah, because this one is very important when we do the analog programming. Yeah. Even this one is in my slide also I have.
Maybe it's more easy to remember.
Yeah. download and see. Try to convert, download, and see what you require.
I want to ask, the unique D here is to, what's the,
Vision.
D, let's say D12, D6, the D
Data register.
data.
Yes.
M is memory.
M is memory. Because M is just a boolean, just on or off only. Only data register can keep these values. Word, double word, and real. So can keep values.
Okay.
Okay?
Close the door for them. That's the letter is so.
Okay. So we take a break. After the break we continue. Okay, so we test yours. This test power up. As you can see, power up.
So this is a transistor and relay type, right?
Yes.
So which one is better?
Okay, for machine is relay type is better lah. Depend on what type of the output. So let's say the output is just contactor, on off motor, lamps and valve, right? Then relay is better. Transistor is if you want to control a servo motor or stepper motor, because transistor means inside of transistor, right? So it can pulse very fast, on off very fast. So it can control the movement of the motor. So relay cannot do that. So it depends on what type of output you are using.
So it comes to motor.
Depend on this. If you are using stepper motor or servo motor, then you must use transistor.
Relay type cannot be.
Otherwise, any relay type can. Even transistor also can, no problem. But the thing is, transistor, if let's say higher current, can burn the output.
But I know that the servo motor itself has a driver already.
Yeah, driver. Okay. Then the PLC. Okay. So PLC need to send the signal to the driver. So normally PLC, the main signal is two signals. One is the pulse and one is the direction, forward, backward, right? Another one is the pulse. So the pulse must be fast.
So we need a transistor can move
Yes,
on or faster.
on or faster. Because I want to test this one.
I
This
bring
one is
here
okay.
I bring here also because maybe it's another option for you to advise your student or.
Yeah, that's why. I know MSA Motion also have this one. But MSA, yeah, how much this one? Yeah, this one a bit expensive than the one that day I showed you another
the
one.
one with the antenna also. Yeah, internet.
Don't have internet. This one got internet, yes.
Yeah, that's why I buy this.
Yes, because now AMSA Motion actually. Why is so many hands? I don't know. Okay, AMSA Motion is they are famous for cables. Like I have a cable actually. I bring later I need to, because this one need a cable, right? So AMSA Motion they are famous for cables. Okay, then what happened? They release their own PLC, but they don't have their own software. They use the Mitsubishi software. Actually, this one is for Mitsubishi, right? They have another one similar like this, but a green color for Siemens. Yes, can use Siemens software, but not the big one or the small one Siemens. I mean, this one can use for practice practice all that. Why you want to waste money on the Mitsubishi one, Mitsubishi expensive? Well, I can do for small projects you can use. So this one can extend, right? But I'm not sure can use Mitsubishi's extend or not. I'm not sure about the size of this one. Okay, so now trying to communicate. So I really got it because for last week we not here. We went to Singapore for training. Really got hands. Okay. So see this one Mitsubishi cable You see the brand? Because the AMSA Motion they are famous for these cables, communication cables, all type of communication cables. Mitsubishi, Omron, Siemens, Bradley, all type of communication additional cable. Last week we went to this company, RGR Plus.
Japanese company?
Not sure. I'm not sure the. Yeah. I don't think so. It's Japanese because why? Most of the PLC they're using is a Siemens. And the latest machine all they buy the latest machine all from China lah. So it's Innovance. They use Innovance.
What's their
They do classes.
oh, glasses?
These classes. Like for like big buildings like gas. They supply for KLCC, the airport and overseas lah. So they have Siemens, a few models. Then Innovance. They say they have Innovance and Omron 1 or 2 and so on. Because Japanese company, then if Japanese company mostly is Omron or Mitsubishi only. It's two only. Mainly Mitsubishi, like the Toyota. They use Mitsubishi. The last time when we went for training, then that day, a few weeks back, I have a Resonec, Japanese company. Then Showa Denko, Japanese company. They use Mitsubishi. Okay. Now you minimize this. Because this laptop have GX02, right? Okay.
Yes.
Before that, I connected this cable, right? So this cable is a USB, correct? Okay, but at your PLC is a serial, correct? The round pin, is a RS422.
Oh,
Correct? Okay, it's RS422. It's a serial cable. Okay, and when it go to your laptop, it's a USB.
Yes.
So even though it's a USB, it's still a serial cable only. So we need to check the COM port. Okay, so you go here. No, here the search. You search device manager. Yes. Oh, go to ports. Oh, I think need to okay. So what happened is, can you see the USB here? USB serial.
Yes.
Yeah. So the driver is not installed inside that. Okay. So we need to download the driver. Actually, from the website also can download. I show you. Because whenever you buy something, a converter, this one we call converter lah. The serial to USB converter lah. So we need to buy, when you buy the cable, sometimes last time they give you a small CD lah. But nowadays no, nowadays you can download from the website. Okay. You click here, the internet, yeah. Just click. You on the Wi-Fi. Yeah. Okay, you click the arrow. Okay, it's connected. Okay, now you minimize this. Go to Google. Yeah. Okay. You search for AMSA motion. This one for the cable lah. AMSA motion. Okay. You see, so this is what you buy, right? Okay. You see, some motion when you try by, you see this one Siemens cable, Mitsubishi cable, all that. Okay. You click here, AMSA motion, space, SC09, S Singapore, China. Okay, this one. First one, yes. Because this is the cable.
Oh,
The cable model, you can see the cable model there.
okay.
Okay, you click that. Okay. Okay, you click here. This one, the driver, yes. Okay. Go down, go down. This one. So this is the cable, right? Okay. Go up. Okay, click this driver down. Okay, go down. So ours is the what?
Model.
The driver name they call CH340. Yes. Okay. Go down. Go down. Go down. Okay. So this one. Yes. The link is many times. Okay, come on. I have the driver. I give you the driver.
Always, I thought the driver only for the unit itself. Now cable also need the driver.
Cable need to driver. Actually, unit. If you ask me, unit don't need driver. Unit don't need driver. Because why? Let's say you buy Mitsubishi.
Yes.
You already installed the Mitsubishi software, so can communicate already, no problem. Only the cable only. So that one also depend on what type of cable.
It means different cable, different software.
Yes, of course. But it's based on the brands, not Mitsubishi, Omron, different brands. Okay. So for example,
Yes. Sir.
So if you see Mitsubishi at the back, they have a USB, right?
Yes.
Okay. So for USB, also you need to install the driver, but the driver is come with the Mitsubishi software. It's together. Okay. Okay. So okay. Then the because the driver is come with the GX workshop. If you are using serial, okay, because serial means because why? Last time, let's say this is the PLC, so this is the round pin, right? Okay. So our PC don't have this round pin. Okay. So what happened? Our PC have the 9 pin. They call DB9 last time. Okay. So what happened? If you convert this, it will become 25 pin. Then 25 pin will be here. This one is a DB25. I have the number. I show you. So this one. This is the cable. So they have like this lah. So this one go to your PLC, this one go to your laptop. If you want to use this one, no need driver. Okay, no need driver. So why they have like this? So this is for the FX series. If you take out this one can connect to the A series. Because A series is using this. FX series is using this. Okay. Now my laptop don't have. Nowadays where laptop have this one? Don't have.
USB.
So what I can do, I can use this USB converter. This is a USB converter, RS232 to USB. This one can convert any RS232. So this one is RS232. This one is RS422. So when I connect this one, then go to your laptop, right? So it won't be a USB, still a serial port. Like just now we test, right? Okay. If I want to use this one, I need to install this driver. Okay, I need to install this driver. Okay. Now, this cable, we use this cable, right? It's direct convert to USB. Correct?
Okay, yes.
It's a direct convert. It's not like I need another one.
Yes.
So if I'm using this one, I need to install this driver.
I understand.
Yes. So if you're using direct, right, like this one just now, direct, no need driver. So any PLC same. This one is like Omron one. So like Omron. Actually, this one I made myself because very straightforward. Actually, this one also why you can make yourself. This one, but this one you are soldered to solder very hard to solder. This one very easy to solder. So all my Omron cable we make ourselves. So this one go to the PLC. This one go to your laptop. Now this laptop don't have this. So I have to use this one.
That's why if you come to USB, you need a driver.
Need a driver because the USB need to convert this RS232 signal into USB. Okay, so now this one don't have. Wait, I have in my pen drive. Let me check. Because without the driver, I cannot command.
How about the internet?
Ethernet no need driver.
What means, is it possible to link with the internet?
Yes. Can link no problem. But let me.
Oh, just try, right?
I want to try the
Yeah.
serial first
Sure.
because it's the new PLC, right? Cannot configure. danger symbol, right? So once I add the driver already installed. If no means I need to manually click update, then I need to choose the file. Like this, for example. And this one, right? Then need to choose and install. If it didn't install automatic. Now after I add the driver, so the computer automatically search and install already. Okay? If you want this one, I just put in your folder. Because later you want to use in your laptop, right? But you need the cable. And by the instant for Shopee also. But normally I will buy from one shop here in Shala.
Oh, Shala.
The same one only. Compared to Shopee price around 20 ringgit extra lah, 20-30 ringgit extra. So why I prefer this one? Because we buying cables, PLC parts since 2014. With them almost 10 years plus. So if the cable I buy anything problem, I can return, I can replace. If I buy Shopee means can, but leceh lah the job to do that. That's why cables, particularly cables lah, I buy from them. Others then I can buy from Shopee, eBay, right? Amazon.
Cable, their lifetime warranty.
Not lifetime warranty lah. If like 6 months I use suddenly a problem or something, I can give to them.
Okay.
They can, because I know them since 2000. My boss knows them, and myself I know them since 2016, almost 9 years. Because last time when I and my boss go to KL, so normally like let's say Monday is training, we will travel on Sunday. One day before we go, right?
Yes.
My boss always go to the shop first. So he tell me like, you see, what do you want to buy for training? Go buy. And I go see, check whether we have one, the cables, even the servo motor, servo drive at the back. You see, I buy from them. What they do, they have all refurbished PLC, all they have. Sometimes for training and use refurbished PLCs. What they do, they buy, company will scrap, right?
Yes.
Company will scrap. So there's another company, they will buy all this scrap. Then they will check which are the parts they can sell. So this company, they will buy the PLCs. Once they buy, they will check all that, check everything, clean, refurbish everything, okay, then they will put it for sale. So for training, sometimes we buy.
Yes.
Training can buy one.
Okay.
Okay, so now COM5,
Yeah.
COM5 just now. Okay.
Yes.
Now you go to your GX Works 2. Works 3 only. Works 3 cannot. GX Works 2. Open this. Go to online. Read from PLC.
FX5U.
FX5U, yes. Change here to COM5. Double click.
Okay.
Okay. Connection test. Successfully connected. Okay.
Yes.
Then click OK. Check it. Click OK.
Okay.
Yep. Okay. Select all.
B6.
Main parameter device, no comment lah. So let's try to read. Close. Close. Okay. So there's no problem inside. Empty lah, right? Okay. So you go to edit. Ladder edit mode is similar to GX3, yeah. Okay, right? Okay, you try to create one program. Simple program. Okay, compile. Save. Some build, okay. Then write to PLC.
So this one the parameter or everything?
Everything can. Okay, done. Okay, monitor. Okay, you shift enter. Shift enter. You click that, shift enter.
Shift enter.
Yep. Shift enter. Oh, cannot lah. Oh, I think I cannot. Okay, what do? You go edit mode. Ladder edit mode. Because Mitsubishi means can shift enter. Right mode. Turn change to M0 and turn change to M1. The X change to M0 and M1.
M0, M1 is
Memory.
Y side.
No, why okay?
M1 is normally close.
M1 normally close. Okay, compile.
Same monitor also.
Yes.
Shift control.
Yeah.
Oh,
What happened? Because why? I think because this is using AMSA motion drive, that's why you cannot shift enter. If no, if Mitsubishi, if you shift enter means the X input and become like on off. But this one cannot.
No.
Uh,
What's the difference? M0.
okay. Why? X is a physical input.
Yes,
Right?
yes.
So
yes.
you need the wire lah to
Yes,
connect.
yes.
Okay. So but actually if you click shift enter, what happen? It become like a one pass, like on off. Okay. Okay. But just now we try cannot. So
Yes.
what I do, I just try the memory. Remember in the HMI, we use the memory to do that.
Memory is not.
Memory because only is inside the
not
PLC.
physical
Yes.
parts.
Yes.
That means if really come to X, they really need signal.
Yeah, really need signal.
This cannot simulate the
Mitsubishi means
signal.
with Mitsubishi, you can simulate, but it won't be like always on lah. It's like a pulse only.
Does this one without a function?
Yes.
Okay.
You try to do a simple program and see the timer, because I'm not sure the timer, what's the value, everything.
Can, but all with MO. All with MOs, right?
M enough because the start stop enough, output okay. Then you use a timer. T0, K100, then cut off, right? No, we must go to edit mode first.
Oh, yeah. True. Yes, timer working.
Okay, no need M2, you can use the Y also can. Right? Right.
Oh yeah.
Ah.
Yeah, yeah.
Yeah.
Yes. Okay. The set.
Set. What?
Set is a set the time, right?
No.
Set,
Set, you
keep
must set.
running.
Want to run what? Set what? Set means must put, not cannot put value. Set means just set one output. Any output. Memory also can, any Y also can. Cannot be value.
Okay.
TON. Cannot use TON. T0. Yes.
There is a TOF, TON,
Ah.
TB.
TOF, TON, TP cannot use for this. Only
Five.
can use for 5.
Okay, okay. And VTO.
Yes.
And okay, we can use this too.
Yeah. Yeah, you put the AMSA motion test. Good. Okay. So this one okay, understand? Now, what we do, we go to analog program. First, we see what is analog. Now, analog means range. Okay, means value. Okay, very simple. So digital means just on off. Okay, on off. Analog means value. So you can measure into voltage and also ampere. Okay, so voltage is 0 to 10 volt, negative 10 to positive 10 volt, 2 to 10 volt, and few lines, right? Then ampere is 0 to 20 milliamp or 4 to 20 milliamp. Okay. So how it works? Okay. Now, so we have the CPU, right?
Yes.
The PLC come with the, we connect the analog input module, okay? Or it's a built-in. So we see this PLC is a built-in analog input. You can see here analog input here.
AD.
AD and D. Analog input and analog. Okay. Now, so we can use a transmitter. So let's say we connect a temperature sensor, right? Let's say a thermocouple or PT lah, right? Okay. So this one we could, because directly cannot connect,
Yes.
unless my analog input is a temperature input. Because only for temperature they have a special module.
For PLC.
For PLCs. I have later I show you in the manuals, okay? So they have a special modules only for temperature. Okay. Other than temperature they don't have. Okay, so if you're using special module, then temperature directly can connect. Okay. So if you're using other modules, then it's like you must use transistor. So transistor, the transmitter. Okay. Why? Because if you see thermocouple, it will be in millivolt. If you see PT, it will be in ohms. Right. RTD. Okay, will be ohms. Okay. So millivolt and ohms, my analog input cannot read, because my analog input only can read these two only.
Ampere, yes.
Ampere?
Milliamp can.
Milliamp can lah, but that one is millivolt.
Yeah, but voltage volt
Cannot.
cannot. Because of milli, that's why cannot. Right?
Yeah.
Okay.
Even the ampere also cannot, because this is ampere. That one is a millivolt. So we won't get a correct value. So that's why we need a transmitter. Okay, so the transmitter will convert this data into 0 to 10 volt or 4 to 20 milliamp. Okay? Then the transmitter, okay, of course, normally we have a temperature, we have a transmitter. Pressure means it's come with the pressure transmitter together, right? Okay. Then, because my CPU cannot read these values, correct or not? So my CPU will convert this value. This is called analog value, will convert to digital value. Okay.
Yes.
So in the PLC, you get this number 0 to 4000, but depend on the modules. Okay. So now, because this analog is a built-in, it's already with the PLC, right? Okay. That one is 0 to 4000. If you add modules, that one will be different number. So that one back to check, you need to download the manual. Okay. So you get this one. So let's say the temperature is 0 to 100 degree, right? So I convert to this, then I need to scale convert lah, because my analog input is 0 to 4000, right? I need to convert to a temperature value. degree, but in my PLC it shows 4000. So I cannot just use the 4000 show in the HMI. I need to do the from here to here. I need to convert. So it's a linear scaling. Here I need to use the formula, right? So this is where we will be using these calculations. So you can do your own calculation also can. They have a instruction called SCL instruction. SCL. So you can use that also. So you have two options. So you can use this one. Manual calculation means you need to calculate that. So you need to get the what is M. So what is M? M is the Y divided X, right? So it's a delta Y over X. So we need to get the Y and X first, okay? So Y max minus Y minimum, X max minus X min. But this is not only formula, there's many formula. This is the standard one lah, linear, okay? So first you get the delta Y first, I mean the difference lah, right? Then get the X first, then divide, then get the N. So your X is your analog input, okay? Then C. So if you have a C means for this one no need, because 0, right? If let's say the temperature is like this, starting in 10 to then I need to calculate the C. So if you want to calculate the C is equal to Y minimum minus M X minimum. Then finally calculate. So many calculations. So there's many ways to do it. So we see one by one how to do it. Okay? Okay?
The transmitter come out confirm is let's say milli, there is no milli and no, is there no milli, right?
You mean after this? Or so it's a thermocouple. Thermocouple is all millivolt. Unless my analog input is, for example, I use CPU, then the CPU means my PLC, right? My analog input is the temperature one. Okay? Let's say TC, then the thermocouple directly I can connect here. Then for this one, I need to do the settings because thermocouple I need to select type K, type J. So here I straight away get the value in Celsius. Depend, later I show you in the manual, you can see. So it's no need a transmitter directly can. Why? But if DC means DC lah. If you buy a RTD model, what PT then you must use the RTD one. But let's say my analog input is a normal, common analog input, means only measure these two, then I have to use the transmitter.
You need to add one more
Transmitter lah, yes.
transmitter.
Transmitter, yes. Pressure but pressure, humidity or normally come with the transmitter already.
I think you need three: CPU, analog, transmitter, so
Yes.
sensor.
Yes. For temperature lah. Others all is like already built-in transmitter. Because why temperature they make it? I think because temperature they have this one, this module. I mean the special module. It means the temperature you can directly go here or go to the transmitter. If no means others are like pressure, humidity all is already built-in transmitter. So it will give you the analog value.
So that the analog input beside the CPU, that one is just a normal type.
Yeah.
Normal type.
Yeah.
Unless what you say that if we get the RTD type,
Yes. It's a,
then we no need add the
yes,
transmitter.
correct. Okay? Good.
Yes.
Now, what we do, we go to minimize this. Because now, why you do this?
So,
Because we're going to do new project anyhow. Okay. Now, this one got analog input, right?
yeah.
Okay. So what is the address? You know what is the address?
Address.
Because you see, if you connect this push button, you need the address, right? So you go X0, X1. Now I want to connect analog input here, right? So what is the address? No address, correct? Okay. So to get the address, we need to download the manual. From the menu only we can get the address. Okay. Now, like this. The address won't be X or Y because it's a value, right? So will be in SD. Special data register. Okay, like SM is a special memory, right? It's all this Mitsubishi one.
Yeah.
So SD also is special data register. Okay? So what we do, we go to Google. Okay, what you do, you key in FX5U space hardware manual. Okay. Easy to be download. Okay, no, not 4 pages. Okay. This one, no. Okay, what do? You go to FFL, analog programming. Hardware manual take up. No, can choose this one. Can. Automatically. Okay. It's 450 pages. Okay. So this one got analog controller. Okay. Because got so many different manuals.
Yes.
Okay, you click here. So this one for the analog manual. Okay, you click here. Okay, so you see here, all the manuals they have. This one is the building. Okay.
Yes.
Then this one is the adapter. Adapter means is like this. On the left hand side into that. It's like this. I have, but I don't have for FX5. It's like this. It's analog also.
Extra input output.
Extra input, additional line, but this one must add on the left hand side.
For analog.
For analog. No, adapter means ADP. ADP. So you see this one got ADP, right?
Yes.
This one if you buy, you need to add on the left hand
Normally
side.
we add here, right?
Okay, I tell you. This one. All these three ADP, okay. This 4 ADP. This one all what? On the left hand side. Okay. Then wait. You click here. Expansion. You click the specification because you go to I want to see the model. Procedure to execute. Okay. System configuration. No, okay. What do? You go to JSOS 2. Sorry, JSOS 3.
Yeah.
Because there you can see
Just see
the model number. Because the model number you can see which one on the left hand side. On the right hand side also can add. So there's a different modules. Okay, you go to project new. Okay, click on this one, the navigation. Parameter, no, module face. Okay. Okay, wash table and make close wash table. Okay, choose element here. Yeah. Okay, can you see analog adapter? Okay, so all these ADP, yeah.
Yes.
If you click, you just drag. You click and drag. Can you see on the right hand side?
Yes.
Okay, you put it back. No need. I don't need.
Put it back.
Can delete, no problem. Just delete. Yes. Okay, can you see this analog input?
Yes.
Okay, this one is just for AD only, right? This one is on the right hand side.
What's the meaning of adapter here?
Because they call it adapter, I'm not sure why. It's a small unit lah. The right hand side they call expansion unit, expansion module. If you want to add on left hand side, it's like they call it adapter. Only for FX3 series they have this. I mean FX series they have this. So they have two types. Means you see on your left hand side, right? On your left hand side, you only can add two types only. That is communication and also analog. Okay. On the right hand side only you can add input module, output module, analog input, analog output, motion module, temperature control module. Go down. Got so many types on the right hand side you want to add. Pulse module, right? All that.
Question, since there is an input and output, but I'm not understand what is analog or the adapter function.
It's just an additional input, that's all.
Input also.
It's a, how to say, okay, it's like this. So means okay, very simple. So I have a FX5U, right? Okay. So now Mitsubishi give me an option that you can add modules. So if you want to add expansion modules, you can add expansion modules.
Yes, yes.
So what happened previously, the FX1, FX2, FX1 and 2 lah. So what happened, they add on the right hand side only, like digital input, digital output, right? Then you want to add the analog input, analog output, any special module like the motion controller, okay? For the servo, right? For servo. Okay. So what happened after FX3U? Only 3U only can use, 3U, then after that 5. So what happened? They see because they add another modules you can add here on the left hand side. Okay. So what happened? On the left hand side, they want to add. They give you an option that is you want to add a communication because here, let's say, because like FX5U only have Ethernet, don't have the RS232.
Yes.
So I need to add something.
Okay.
So what happened? They give you an option that you don't need to add here. You can add here.
Yeah.
So they give it a name like adapter. That's all. This one all we call it as a expansion module.
Oh, sir, your means if let's say we need to use the analog, so we need to have an internal analog adapter,
Yeah.
so that we can add either in or out
Oh no.
from another side.
No need. It's already a module already. It's not an adapter. It's already a module. They call it's an adapter, but analog adapter means it's come with the 4 analog input.
Oh, with the input.
Yes, together.
Together.
Ah.
That means not necessarily I need to
No
add.
need here.
If I want, also no problem.
Can.
Yes.
Can.
Either way.
Either way.
I
Either, so, okay.
Oh, okay.
Now I get, okay, how you take this, okay. Now here I can, but here maximum only can add 4 only.
Okay.
Depend on the module lah. If I'm mistaken, only can add 4. Okay.
Okay.
Now this side can, so this one all we call it as a adapter, right?
Okay.
Okay. So it's not like I want to use analog here, so I must put analog here.
Oh.
Not like that. Okay. So what happened? They see here, because you want to add the IDO, all that, okay? It occupies space,
Yes.
bigger. The module is big. Okay. This one is module slim. Okay. Now another trick also here, because here also analog, but here only can add analog and combination only. There's 2 adapter only you have, right? Input, output all don't have. Okay, that is number 1. Number 2 is a slim compared to this. Number 2. Okay. Number 3 is this value they call resolution. Okay, the resolution means if let's say it's 0 to 10,000, right? In the CPU you get 4,000. Yeah. It means so the resolution here is low. It means 0 to 4,000 or 0 to 16,000 something only. But this analog, the value is big. Okay. So for example, if you connect 0 to 10 volt, here you will get 0 to like 16,000. So it means it's like more accurate value you can get compared to this. Okay. So now let's say for example, I connect motor rotating. I want to take the speed. Okay. Let's say the speed. I just want to calculate how many hertz only. Okay. So 0 to 50 hertz. The number is not big. Okay. So I just can use this one. But let's say I want to take the RPM. It's a 0 to 2,000 RPM. So the number is very big, and I want a very accurate number. Then I can go for this one.
So the 0 to 16,000 is under beat or
Under word.
words?
Yes. The data will go into your data register, the D. But it will be the SD or the normal D also can. It depends on how we do the configuration.
So means maybe this side already no space, so I still able to add from
Analog.
and that's by the weakness if
The bit is
the
not
piece is
small. Yes. I can show you the manual. In the manual I can show you. Okay, go to the manual. You go to the manual. Okay. So you see, let's say I'm using a 4AD, right? Analog input. Okay, you click here. Okay, just go down. You make it bigger. Okay, go down. Just scroll. Okay, wait. Go. Okay, you see, so what is the range? If you put 0 to 10 volt, okay, the range will be 0 to 16,000. Okay?
Yes.
Okay. So that one is for your adapter, right?
Yes.
Okay. Now you go down. No, here. Go down. So go down. Okay. Now we are using the built-in analog, right? This one. Correct. Now it's a building. You want to use the building, yes? Okay, you click that. Okay. What? Okay, can you see here? What is the range?
4,000.
0 to 4,000. Okay. What is the address? Can you see SD6020? This is the address. It means this is where you get the the value. Okay, so it means for this PLC I got analog input got 2, AI1, AI2. So the first one is SD
6020.
6020. The second one is
Six
SD
zero,
60. What?
6060.
60 means if I connect a temperature transmitter
Yeah.
to my input there. So this is where I get the value. What is the value is 0 to 4000. Okay? Okay? Let's say I want very accurate number. Right? So just now this one is not 0 to 40. Just an example, right? Okay? So just now we see it shows 0 to 16,000, right? 0 to 16 or 0 to 12.
Sorry?
Just now the value is 0 to 16 or 0 to 12,000? 16,000.
16,000.
So, okay. Now, let's say I want the temperature very accurate. So I cannot use the built-in analog input. Because built-in only the base range, not big. So I go for this adapter. Or this adapter. I think this adapter must be bigger than this. Okay? Hold on. Order food. Because now later lunchtime someone is coming. Okay, you go down. We get the
Before that, I still need to ask something.
can sure no problem.
Okay, what I know, the built-in is 4,000, right? Just now.
Yeah, really for the.
Okay, if this is
This one
the.
we don't know because later we need to check
Okay,
the menu.
that means this one is 16,000.
Yes.
Oh, okay.
Because this one just now the ADP type. I just
Adapter type.
adapter type. If not adapter type, we just show you this only for the only. So that one will be later we see what is the value.
Okay.
You go down. No. You just scroll down.
Yeah.
Okay. This one for analog output. Analog output, what is the address? The
SD
SD 6180.
6180.
Okay. So the range also same, right? 0 to 4000.
Yes.
Okay. So we take note this. You take note this one. Analog input 1, analog input 2, analog output. This address you take note. Because later when we do programming, we need that addresses.
Okay, question is,
Yes.
but this analog output is this side, right? Is this it? Oh, this side.
Okay, now this analog input or output, this one is inside the built-in.
A built-in one.
Built-in one, okay?
Okay.
The one here, okay. Now, but when you want to add an adapter, is not there's no like input output. It's not like you don't need to look like okay, input must be here, output must be no. Because the adapter here itself got 2 type adapter. You go up. No, here. Okay, you close this one. No, go up. Close this one. No, I click the arrow. Click the arrow. Yes, okay. You see, you have 4 AD. AD means analog input adapter. Then you have 4DA, which is analog output adapter.
Analog input.
The AD means input, DA means output.
Okay.
So means
D to analog. D for.
okay? Okay, it means this module here got input also got, output also got. Both you have.
Oh, okay.
Then there is a module with both combined together, which is this one. This is a combination. You click that. Okay, this is a combination of analog input output. You go down. Can you see? Analog input, digital output. And can you see input voltage, output voltage, and everything. Go down. Analog input, analog output specification. Can you see? So this module is a combination module. It means let's say I can add 4, right?
Yes.
Okay, let's say first one is the COM, right? Second one is I can add the analog input module. Third one, analog output module. Fourth one is analog input and analog output module. Also can.
Okay. Yes, I understand.
Yes.
Just me a little bit confused.
Why they have both sides, right?
Yeah, because now I'm thinking. Just now I listened to you. This side is more slim.
Yeah.
More slim. The advantage is more slim.
Yes.
But the resolution is smaller compared to this side, right? Okay. But this side we still do know what is the
resolution.
Yes. But so far we know it's 1006 for adapter side.
Yes.
But built-in is 4000.
Yes.
Either in or output.
Yes.
Okay.
Yes. Even this the adapter side is a in or out is a 0 to 16,000. In or out doesn't matter. Analog is 16,000.
Yeah, combine many types input or modular, output modular, combination of modular.
Okay, can?
Can.
So this one for this module. Okay, now maybe you can download this. You can download this, put in your folder. Go to desktop. Go down. Okay, TWS. Okay. You put it here. No, you change the name. Okay. FX5U. Space analog adapter. Okay. Save. Alright. Now you go back. Analog programming. Okay, go down. Analog module. Okay, no. Slowly. This one. Analog module. Because this one is a 500 page. Okay, you click this. Okay, you click here. So this one is a normal analog input module. It's a module. Can you see? It's not a adapter. It's a module type. Okay. You click on the first one.
This one.
You click the arrow. Okay, can you see the for AD only, no ADP something. Okay, you click that. Can you see? You must add on the right hand side.
Yes.
Okay. You go down. I'm not sure what is the resolution for. 4 point.
Current
What is the resolution?
32,000.
32,000. So
much better.
much more bigger. So now let's say your project you have analog temperature to measure or pressure to measure. So it depends on you whether, because let's say this is the COM. Okay. Now here also you have analog input, right?
Yes.
Sorry, this is 0 to 4,000. Now it depends on you which input or output you want to use. But previously they don't have. Before FX1, FX2 all they don't have. FX3U and FX5 only they have.
Have me built-in.
The adapter.
Oh, adapter.
Yes. Before that, all they used only the expansion unit only.
But let's say if 4,000 is not good enough for the temperature.
It depends. Okay, if let's say that 4000 is okay. But let's say if you want to get very accurate value, okay. You see, 4000 means I need this one to copy it. Okay. See, so let's say that first I need to divide this 100 divide 4000 0.25. Okay. Now let's say here is 2000, right? In
Yes,
middle.
correct.
Okay. So if there's a slight change, 2001. Okay. So 2001 times 0.00. So I will get the reading is 50.025. Okay. But let's say if I use 32,000. Okay. So
More decimal point.
more decimal point, more accurate. That's the difference. There's no much difference. Let's say I have multiply 16 after, right? And there's one change. Just one change, one number change. Because just put it here. Like, let's say 0 to 32,000.
Yes.
Half is 16,000, right? Let's
Yes.
say there's one change, 16,001. Okay, so I will get here. Just put 50.003. Okay, so which one more accurate?
Because of 32,000.
Yeah, so that is the main difference. So this depend on what type of sensor you are using. Let's say the sensor I'm using is what? Only Brands. Okay. Because this number is not much different, right? Because 0 to 100, there's no much. If I change to 0 to 10,000,
Yeah.
0 to 1000 degree,
Yeah.
then this one is 500.2 degree. This one is 500.0.
Yes.
Yeah. So this is the one that playing the. Did you choose which one you want to use? Because I just think of bar. Because if you want to calculate bar normally 0 to 10 bar, 0 to 20 bar. But if I want to convert that into Pascal or kilopascal, of course lah, then Pascal the range is more higher. Then in that case, I try to use this.
With your experience, is it so far did you use the 3,000,
Yeah,
32,000?
yeah. Many companies they use this one. Number one is of course 32,000. Number two is, if you ask me, they want more reliable lah compared to this. This one reliable, easy to get compared to this. Because this one small one, right? The cabling also very difficult to connect. Okay, it's just like a small one. Can you see right? Small one. This one is it's a normal screw, normal like a screw type. So easy to do wiring, easy to do setup, everything. And more advantage they have. The advantage is okay. Okay, go down this one.
Yeah, so before that,
Yeah,
this one is without the address, right? Because it's not
No,
building-
this one no address.
Because it's not a building type, right?
It's not a building type.
So
For the adapter and also this extension, no address. So where to put the address? In your here you add this PLC, right? Once you add, in the program you need to put the address. If actually GXWorks 3 can put, but if you're using GXWorks 2, cannot put the address also. So what you have to do is there's a function called from. like we do the match function, right? Add something like there's a what instruction called from. From means okay, you need to select from where. So there's about 4 data you need to keep. From, okay, this is a PLC, okay, unit 1, 2, 3. 3, right? Okay, so from unit number 3, which data you want to take? Okay, this one got how many data? 4 input. So from where you want to take? Okay, data. So you what? Module 3, first data. How many data you want to take? Let's say only one means only one. 4 means from the first 4 data, then where you want to store. So you need to do this function.
Confusing.
Yeah, confusing. Means it's like okay, the function is like I take data from this module, starting from first data. How many data? Let's say 4 data I want to take. Where I want to store. So I need to choose a D. Same lah. I must put my own data register. So let's say I choose D0. Let's say I take 4 data. So means your D0 will be your first analog value. D1 is second analog value. D2 is third. D4 fourth. If let's say I put from module number 3 first data and I take only 1 data, then I put into D0. It means only the analog, first analog input only inside D0. If you want to take the second one, take the second one. Okay, that one. So you must use the from function. And also if you want to take not only the not only the analog value, if you want to get some other data, it means like whether the module is okay or not, whether the analog signal is it in range or out of the range, all that you want to take means you must use that function. From, okay, what is the value? You go down, I think it will be here. Somewhere here. Go down. So can you see the range, everything is here, right? Okay, go down. Go down, go down, go down. All this in the range. Yeah, go down, go down, go down. Go down, go down. It's just showing accuracy, all that. Go down. Okay, terminal, okay, go down. Then the LED, go down. Okay, got alarm, right? Procedure before, okay. Go down, go down. Go down, go down, go down, go down. Range function, disable setting, go down. Go down. Just scroll down only. No, just scroll down. Go down. I want to see it come like a table. If you see a table, then stop it. No. Okay, go down, go down. No, maybe you click here. Click this arrow. Okay. Troubleshooting program. Maybe okay, go to parameter setting. Just click. You see, like I said, in the software I have to do this, right? The settings lah, okay? Okay. Application. Okay, go to click on the program. Go down. Because it's showing that. Go to appendix. No, click the arrow. Go down. External buffer memory area. Okay, go down. This one. Yes. You see, this number here, okay? So what is the this is numbers lah, okay? Numbers, okay. Then this is the error code. So firmware version, system, okay. Go down. Okay. Let's say system area, alarm. Okay, go down some more. Okay. Go up. Okay. Anything I want to read. Go up. Latest error code. Error code, system, module, system. warning. Okay, for example. For example, I want to get the warning if my signal is more than 10 volt. So if more than 10 volt means it will be more than 32,000. Okay, but how I know, right? So that is where you can use the from function like just now I said. Okay, so it's like this, but this one I'm not sure the building got this function or not. Later we'll try and see, but I don't think so building have. Normally this type of module only they have. Okay, it will be something. Can I erase this?
Sir, before that, the 4,000 built-in actually is not designed for temperature, is it? Because they're so
No, it's
so
small. Yeah, it's not like designed for time. Not like that. Actually, you can use any input there, so can. It depends on the programmer. If you want a very accurate numbers, then you won't use that. Even you ask me, so I won't use that.
Normally 4,000
It's very small.
is more suitable for what type of
Like a motor speed.
horse.
No. The inverter speed. This blue color motor, right?
Yes.
Because later we will use that motor to with this PLC.
So to control the inverter.
To control the inverter, let's say I want to control the speed.
Yeah.
So 0 to 50 hertz only.
Yeah.
So the speed there's a 0.1 different. I don't care. Right. Let's say the actual motor is running 50 hertz,
Yes.
but in my PLC is showing like 49 hertz. So it doesn't matter, right? So no problem. Then I can use this.
Yeah.
If I'm not reading the hertz, let's say I'm reading the RPM.
Yes.
So of course the number is bigger, right, compared to this, a bit bigger. So, but still I can use 4,000 also. But it depends. Okay, whether I want to use the 16,000 or 32,000. So it depends on what are you measuring is. Whether the value is very sensitive or not. There's a 0.1 change, is it sensitive or not? If sensitive, then I go for this. If not very sensitive, then the usage also I'm not using, big numbers, compare all that. Then I can go for 4,000.
Understand?
Okay. Now what I want to show you that is on this part, okay. I just give you one, the idea, okay. So what they do, okay. Now I want to get if the 10 volt is bigger,
More than 10 volt.
more than 10 volt. So what I do, I will take it because so now how to get if let's say it's more than 10 volt, how I know?
Exit the 3,000.
32,000, right? So how you know? So maybe you can do your own program, or you can use this function called from. Okay, from. Okay. So can you see this one? This number. Can you see this one? The UN G399.
Yes.
399 means these numbers until 399 numbers.
Means 0 to
0 to 399. Go down, I think so, yeah. Right? Okay, go up. Okay, down. So from where? From, I need to see which module is this one. Let's say module number 3, right? Okay. So you can use K3, but they have another format. You can use that format also, I forget it. It's like this U400 or 401 or something like that. But I want you to get an idea, okay? Okay, K3. Then what is the address from K3? Then which one? UN G what?
399. The one.
Yeah.
Warning output flag.
Yeah,
36.
36. Okay. So from this unit, this data, right? Okay. So the address in hexadecimal only lah. Okay. So how many data I want to take? Only one data, right?
Yes.
Okay, only one data. So where I want to stop? Okay. This one is just like on or off. Correct? Because it's just a warning output flag. Flag means it's just a on or off only. Area means it's a value. Can you see system area?
Area is a value.
Value lah. Okay.
Cost.
Okay. So what I do, I put inside M10, for example. Something like this. You need to do the program. Okay? It means I take data from module number 3. Then this is the data. Only one data I want to put inside here. Next I want to take 10 data. It means 10 data from 36. Means 36 until 46. Sorry, 36 until 45 lah. 10 data. I will take this.
Okay.
From here to here something.
That will be K10.
Then it will be K10. Then K10, then I put M10 means from M10 until M19. 10 data.
The M here is the memory.
Memory. Okay.
Store in memory.
Store in my memory.
Take out.
Yes.
Use.
Now I will use this memory.
M10.
Create an alarm. That is my AI is over limit. For example lah, this is maybe is another memory you want to put in your HMI. Then maybe our output depend. Okay. So you see, if building don't have this error codes. So only the adapter and the expansion unit they have this. So now you have a temperature sensor. Now it's depend on you whether you want to use the building or the additional modules. If you just want to convert the value, very simple, just want to show temperature only. Other than that, not important, right? Then I can go for building. Let's say other than that is important, because if suddenly the wire is broken, the value become minimum, right? Minimum less than 0. Then I want the value. Then I check. Okay. So means the conclusion is the adapter and the expansion unit can give you more data. You can take more data from the units. Okay. So yeah, you can go for your break. After the break, we come and connect analog input, try to understand or monitor all that, then try to do some programming.
Very interesting.
Yeah, this one actually very interesting. Very interesting. Unless we have all these modules, because I don't have this module. Very rare I teach all these. Okay, normally, because why I teach you, because you ask me what is the difference. So that's why I open this. If no one, if they won't ask me what's the difference. So I just say, okay, this is this one.
Because,
then they ask me, okay, can I use the additional module? Then they use additional module. Then I will tell, okay, 4,000 and 16,000. Then they say, okay, but why I teach you this one? Because you are now in your mind you are thinking that, okay, I already have the expansion. Why I need the adapter?
yes.
Correct? Why I need the adapter? So that's why I come and show you this.
And because my job task also to more understand this.
Yeah. Because you want to select the module, you are the line going to buy the modules. Correct?
Yes.
So you need to select. Because the adapter cheaper than the expansion. Adapter is like, for example, analog input is 600 something. But the expansion unit can go up to 1,000 plus. 1,900 additional like 300, 400.
The temperature is very quite important to us.
Yeah.
The fact that we call raising the reaction. reaction.
Yeah.
Reaction. That's why we need a chiller. We also have a chiller to produce cold water. So we sensor to scan whether the cold enough. This and that. Some more there is a flow meter also.
Yes.
So inverter, we have Mitsubishi inverter, then motor not Mitsubishi. Then we have the flow meter, so all in together to get more data to produce the products. So once you come to temperature, my question, a lot of questions.
Can. Even I have a temperature sensor, later we can connect also.
Then actually I also facing one problem, but I believe later soon I will understand how to do the setting. Because there is from the PLC come out, there is we put a pump controller to set is to set the flow flow rate.
Okay.
Once we change another model, same brand, another model, but the reading is not a little bit 1 or 2 degrees out.
Yeah, you mean the temperature value or the flow value?
The flow value.
Flow meter value. Okay.
So I believe because of the PLC, there is some analog signal.
Yes.
Is tally to the previous model, but
Okay.
the new model
If
is
one or two difference is okay. If one or two difference means you need to do some changes in the program. Okay. If the difference is bigger, okay, you need to see this one. For example, okay, currently I am using 0 to 1000 sensor. Okay. Then what happened is 0 to 1000 sensor, then you do the calculation, correct? So what happened? Your Y max will be 1000, Y minimum will be 0, you do the calculation, everything is okay. Now, you change the sensor. The new sensor is 0 to 1100. For example, new sensor is 0 to 1100. So what happened? Initially, if 16,000 it shows what? 500. Correct?
Yes.
So it will show 500.
Yes.
Because this value is still same.
Yes.
Because this value is still same.
Yes.
Okay. So when you buy a new one, that one also show the value 16,000 something. But here it won't be because it's a 1100 baht. Right. So here also it won't be 500. It must be like 500.
Because the line already.
Because the line is increased already.
Yeah.
So 510 or something lah. So become bigger. So of course it won't get a proper value.
Now this thing is not a sensor. This thing is just a controller to set the control.
Yeah.
But the input is from PLC.
Yeah. Okay, that's a good. But if one, that's why I say like one or two difference,
Yes.
then it means this range is still same. Means this setting is still same. But maybe previously is they do some changes that is not 0 to 1000. Because of course this cable all will have a plus minus, right? Offset, right?
Yes.
So maybe 0 to 998.
Yes.
Ah.
Yeah. I understand why you
Yes. So need to check again, do some modification.
Maybe not compatible.
Yeah. I mean need to do some offset value others.
So because I don't know how to
Because you need to understand first.
So I
How it works.
add a potentiometer to
Okay.
minimize the signal so then to get tally.
Oh.
But that is not the right way. But just try to let my upper boss see everything is tally. This is idea to
Yeah, your idea is correct. You add a potentiometer to reduce the value, but after you now
it's not the right way.
now you know already. Of course, because before that you don't know about PLC, so you use your wiring knowledge to do that. Now you know the PLC, so you can do some changes. Okay. Okay?
Thank you, sir.
Yes. So I have one. My previous student, so he got a project. So he come here to ask me some questions. Okay, sir.
Yeah.
So what we do first? So we have a signal injector. This one we can inject for 20
Generator.
generator. Then this one.
So need to try to do that.
Yeah. So this one ground and 24 to power up this.
Mm.
We can take from here.
Mm.
Then this one ground and analog voltage.
Mm.
Okay. This one here. V1 plus and the V minus is the ground.
Okay.
For this one, I need another
Oh, this one.
small one.
Thank you.
Malaysia. So cuba dia tu dia tahu apa Google lari. Google faham itu kurang silo bisa. Kira apa yang saya rasa. Dan
Question, sir.
yes.
I see the PLC here all under voltage without milliamp, without any.
No, I mean the building don't have milliamp. Only the adapter and the module one are have milliamp and also voltage. Because in the manual just now download the manual, right? In the manual also you can see only show milliamp. Only show voltage, and the voltage also 0 to 10 only.
Yeah.
You cannot select negative 10 to positive 10 can select. Only this module and this module can select. So that is the main difference. Okay. But if you have a milliamp want to use here, can use what? Resistor. 500 ohm resistor.
Do resistor convert to what?
Voltage to milliamp to voltage can convert. Voltage to milliamp also can convert.
There is a converter.
No, just a normal 500 ohm resistor.
Just put a resistor.
This is for the resistor. So if you want to convert, but I forget to do. There's two ways. One is you jump 0 and the positive you need to jump. Another one is the positive type you need to pass through the resistor and go here.
If a milliamp connect with the resistor will become voltage. What do you mean?
Yeah. There's a two. One is
Yeah, I see someone put the resistor. I thought it's the protection. I didn't know there is a component.
No, but I need to. I forget to know.
Because
It's something like this.
It's okay.
Let's say your device, your PLC is voltage, and your instrument is milliamp.
Yes.
So you connect to cable, right? Okay. So I forget whether I need to resistor put it here, or another one is, let's say this is milliamp, this is voltage, right? There's another one is you must do like this resistor. But this converter, which one? Maybe voltage to milliamp or this one. But there's a two-way to. So you can use 500 ohm resistor. So later we try, because I have a temperature transmitter. That one is a milliamp. Okay. So later we connect the resistor, convert to voltage, because our analog is voltage one. Okay. So I send you a video. Seconds. Want to see? Come and see. Can see the whole. Okay. Can minimize this. Okay. Now. So if you want to use the analog, building analog, okay, you go to parameter, FX5U, module parameter. Can you see analog input here?
Yes.
Okay, double click. Yes. Because just now we do some setting. Okay. That one can be here. Okay. We need to enable this.
Enable this.
Yes. Yes. The sampling is okay, no problem. Channel 2 also. But we are not using channel 2, right?
Yeah.
Then never mind lah. So later when we connect the temperature sensor, we can use the channel 2. Okay? So we need to enable this, then only we can read the value inside here, the SD6020. Okay? Okay, already enabled, click apply. Okay, done. Now we go to program body. Okay, just save first. Save the project. You can put day 3 analog. Yes. Okay. Okay, now you go online. Just go monitor. Just go monitor. No need to write. Just monitor. Okay, go then data. Then go online again. Wait. I think it's trying to communicate. Maybe check the cable, Ethernet cable. Yeah, close, never mind. Close. Hey, sorry, you cannot monitor because we need to download. Yeah, actually, you don't need to download the program, the parameter. Because just now we enable the parameter, right?
Yeah.
So download the parameter. Okay, go to online. Write to PLC. Yeah. Okay, clear, okay? Communication problem. Okay. Close. Okay, go to online. Current connection destination. Okay. This a communication test.
Error here.
Answer is okay.
Mm.
Line 2 is not connected. Line 2 is which one? Okay. Oh, it's not connected. Okay, now okay. Okay, now connected. Yes, okay. 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 Now try to write to PLC. Go to online. Okay. Yes. Write to PLC. You just select the parameter here. Program no need. Okay, execute because we want to check the value only whether I can get the value 4000 inside this SD6020 or not. Yes. Yes. Okay, close, done. Okay, okay, close. So reset your PLC. Not this. Download the parameter, right? Reset. Okay, then run. Still error. What? But can run. Okay, I know why. You know, just now inside there got program, right? The previous program. Okay, because just now we download we only download the parameter.
So, the operate now.
No, not because of that. Earlier got mathematic calculation, right?
Yes.
There's a divide we use, right? So if something divide 0, what I get? Error. Like some value divide 0 error, right? So that is the error. Actually, you can go to diagnostic and check what is the error. Diagnostic, module diagnostic. Can you see? Operation error, right? Okay, down below you can see the cost. A value of 0 was input as a divisor. So it's not the error because of the value. Like, so once that one is clear, then the error will go off. Okay, and close, no problem. No. Okay. So now, so means that the previous file, the mathematics project is still inside there only. We only downloaded the configuration. Okay. Go to online. Watch. Register to watch. Watch window 1. Okay. Go to left. No, go to left. Okay. The name. Okay. Yeah. You put SD6020. Enter. Right click, start watch. Yes. Okay. Now you increase the value.
Yeah. From analog convert to digital.
Yes. So the digital value is this one. So if you go maximum 10 volt, you will get suppose you get 4,000, but I think it will get like 399 something.
Okay, 10.
3994. Okay. So you see what I did. You don't need to download a program, right? You need to download just for testing. So what I do, I just download a parameter only.
Yes.
The program is empty, so I don't need the one. Just want to download and I just want to monitor only. So I can do this one.
Watching, actually just a simulation, something like that.
No, watch is just I want to monitor values.
To check the value.
Yeah, just check the value whether it's on or off, because you can check value for the boolean, right? On or off, or the others like the word, double word, the floating point, all you can check. Okay. So now what we do? Now we see how to convert this, do calculation.
If let's say 4,000, but this one not reach to 4,000 is okay.
Okay.
Or must do what?
No,
Make it
it's
perfectly.
normal. It's normal. Plus minus is always normal.
Okay.
And there's another reason is that it's not an actual analog. It's just an injector only.
Yeah. Come to the sensor, everything still okay with this.
Yeah, still
all
okay.
around there is still okay. Right?
So now what we do, we go offline.
Offline.
I mean edit mode. Ladder edit mode. Click that. Yeah, click.
So,
Okay.
Okay.
Yes.
One more.
Yep. So we do calculation. So what we do, you do subtract. Okay. But all these subtract must use the floating point subtract.
Okay.
Because why? Y divide x. Let's say the temperature we want to use is what? 0, right? 0 to
100.
100, right? So if 100 divide 4,000, we will get 0 point something. That's 0.025 something, right? Okay. So we must use floating point calculation. So actually, we don't need the offset. We just get these two values first. Let's say D0 divide D2, D4, then D6 divide D8, D10. we get this value. So means
Yes.
the y and x. So m. So another dy. This one is a d12. Okay. So once I get the d12, so m already get. X is my analog input. So y equal to m. We do one multiply, then we get the temperature already. Okay. So first we try to do this calculation first. So put the SM400 and do this calculation. No, it's there. I think maybe the wash table will make it smaller.
Question.
Yes, yes.
Is it must be SM 400? If I open, just let's say F5, the open.
X5.
Yeah.
Normally open.
F5, sorry.
Okay. F5.
The cylinders are normally open.
Yes.
But I must put a SM400 so that to become the calculation.
Not necessary. Okay. Why we need SM400? Because if I want to do something here, because here is like always need to do the calculation.
Yes.
Okay. So I always want to calculate. So means the line must be always activate.
So nothing can be disturbed, right?
That's why I use SM400 lah. But let's say if I have an interlock means I do some process. If the process is done, then only I can do calculation. That means here I can put anything. Maybe a timer output, while memory. But for now we don't have such thing, right? So
Yes.
we just like always want to calculate. So I just put SM400.
So that means if SM400 nothing will be disturbed, no
Yes.
signal will disturb.
No
this
signal
line.
will disturb unless I put the interlock here. If SM400 means it's like whenever the PLC from stop to run, I will always do the calculation.
Okay, understand. I thought it's a command so that to do calculation.
No, not necessarily. Because why? Because I need something in front to trigger the signal. If let's say you are using like if you are using you watch table, you close, because your question give me my different idea to teach you. You click on the element, open this. No, element is there. You click again.
This
Then you open.
okay.
Sama open sama. So currently we are using this arithmetic operation lah, right? Addition, subtract. You click here. The arithmetic, yes. Just click once. Okay. You see the multiply, all that lah. Okay.
Yes.
Okay. You close.
Close.
You close. No. The arithmetic. Okay. Go down. Go down. Go down. Scroll down. Scroll down. Okay, so we know that FX5U, they have a function block,
Yeah.
like a timer, right? TON, TP, TOF.
TOF.
They have for calculation also. Can you see arithmetic?
Yes.
Okay, you click this. Okay, can you see ADD, divide, everything? Okay, go down. Okay, this one there's no like. Okay, for if you want to do like a normal instruction, okay, we what we do, we give it a name. Okay, this type is we call is a instruction type.
Okay.
This one is a function block type. Okay, got two different type. So the instruction type, if I want to do normal subtract, is SUB, right?
Yes, correct.
SUB or DSUB or DESUB.
Yes.
This is 16-bit, 32-bit. This is real or float, right?
Yes.
I put float lah, okay? And this here, this subtract, you see, subtract or calculation like that, there's nothing to select like this one, right? Just this one, right? Okay. This subtract, how this subtract works? The normal subtract is subtract data 1, data 2, data 3, right?
Okay.
So for this one, I need a something lah, right?
Okay.
But this type, I don't need. This one is subtract. You will have two value, 1 or 2. So there's no, there's nothing to on. But this one also got two types. Can you see got sub and sub E?
Yes.
E means you will have another line called enable. When you use enable, then you can put interlock. Means when I enable, then only I do the calculation.
Enable means on and off.
On the block, power up the block. Okay. If I'm not using the enable, nothing.
Always on.
Always on. Okay.
Okay.
Then here will be D0, D1, D2. Okay. Now the question is, how am I going to identify whether it's a 16-bit, 32-bit float, right? Right. Okay. For this type, we need to choose this, right?
Yes. Yes.
For this type, we don't need to choose, but it's automatic. It means if let's say this is 16-bit, this is 16-bit, your output will be 16-bit.
Okay.
If this one is 32-bit, your output will be 32-bit. If this one is real, your output will be real. So no need to select.
Okay. But if let's say the result
If there's a difference, then you won't get the proper value.
yes.
Let's say the one is 16-bit, one is real. Of course, real and 16-bit cannot calculate. Then, of course, I won't get a proper
If I
value.
put a big figure is more than 16-bit, is it automatically will go to 32 bits?
Yes,
But okay.
but I need to define that D0 is a 32-bit.
Okay.
Okay. So there's two way lah. This one second, this one second. Mitsubishi people prefer this one. Because this is the old style of Mitsubishi that still following. This one is the new style of programming.
But the new style, let's say, how I know whether the thing is under 60?
That's the problem. We don't know. So only we monitor the value that only we know.
Then we play around, then
Yes. We play around, then later maybe later the D2 they use. Okay, of course if you see like this, of course I know it's a 1660.
Yes, yes.
Because the addressing lah.
Yeah.
Okay. Let's say it's a different addressing. D0, then this one suddenly D50, D20. So how to find out this one? Correct. So what I need to do is I need to check the D50 from where?
The 50,
Yeah.
D50
Where I get
the light.
yes. So from where I get the D50? Then I search, and say from analog input. Then I know, oh okay, it's integer. Maybe from the HMI. Then I go to the HMI because the HMI, right, you can select 16-bit, 32-bit, you can select. So then from there you know. Quite tricky lah. But if you're familiar with the programming, familiar with the
Yeah, of course I prefer the first one.
yeah, of course. If you
More
are
easier. More easier.
You know why? Because in Siemens also they have like this.
Oh.
But in Siemens, there's an option to select whether it's an integer or double integer. But here I'm not sure. You try to drag one sub, you put it here.
Just E or
And without E. Yeah. Just drag and
sub.
Sub also can. The second line.
Yeah.
Yeah. Okay. So there's no what?
No integer.
Cannot select. So no. There's only how to find out is key to find out from where I get. I mean, take out. No need. Okay.
Thank you.
Close. Yeah.
Take back to the wash.
No need watch. There's another. We do this one.
Yeah, the side I need to D0, D2.
Later.
No, what means
I know you want to arrange the D0.
Online.
Can also. You go to online. Watch. Register to watch window. Yes. So we want to add here later.
Okay.
We finish the program first, then later can add. Okay, this up, okay. Second one, just click in there. Another subtract, this up, yep. Enter, okay. Then this one will be yes. Because today and tomorrow will be more to data types, numbers, more to that. Okay. Then you add this one, divide. DE divide.
Okay. Floating point also, right?
Yes, correct. DE divide. Yes, space. Okay.
D4
So,
D1,
yes.
D10.
Yes.
D4 and D10.
Yeah. So we already calculate the M, right?
Yes.
Then M multiply with the X, we will get the Y. Okay, now our X is this one, right? Okay, and this one is not real, correct? Or not? It's a word,
So what?
right? Because just now we monitor this one, we didn't change to floating point, correct?
Yes.
It's a word, right? So how, because my M is floating point, X is word, cannot.
So must change to what? Floating.
Yes,
Okay.
must change to floating. Okay, how to change? Okay, maybe for that you add another SN400.
Okay.
You add another non-open, click here first. Okay, SM400. Okay, now integer I want to convert to floating, right? You type int. Can you see? int to float. Okay, you can choose that. Can you see? Here, converting 16-bit signed binary data to single precision real number. Okay? Right. Okay, you click that. Space. Okay, so we want to do a SD6020.
Okay. SD.
Yeah. SD6020 space. Okay, I need to convert, right?
Yes.
So which data register I can use? D14.
D14.
Yes.
Okay.
Okay. Good. Now we add another SM because why I'm doing multiple, so I can give comment for my lines. Okay. Okay.
Yeah, okay.
Okay. Then now multiply. So D12 multiply D14. I will get the Y. Y is D16. Because I already get the M. M is 12, right?
Yes.
X is
already have.
14.
Yes.
Okay, now we do the multiply. DE multiply to get the Y.
And multiply X.
Yeah.
Okay. M means is D12 multiply D14.
Yes.
Okay. So
Another one. D MUL.
LBC.
Yeah, L is missing. Okay. Then the result where I put Y. So D12 is M, D14 is X.
D16.
Yes, the Y. Okay. Convert first. Convert and save.
The sector need D0, D2, D4, the watching.
Okay, later also can add one.
Oh.
Yeah, after download also can add.
So
Convert. Save first.
Save.
Yeah. Okay, now before that, what I want to do, you bring the mouse here. Yes, edit statement. Okay, click that. Yeah. Now you double click the one. No, I just click here. Double click on the side here. Okay. No, you need to select first. Enable that. Just okay. Then you double click at the side here. Okay. You can add a statement here. Statement is okay. You do like this. Okay. First line is delta y or something. Y max minus y minimum. Y max minus y min. Double click. No, double click, yeah.
Okay, Y max.
No, close. You double click on this one. The first one. Yeah. Double click. Okay. Then you click here. Click enter. Enter is it click? Oh, okay. Double click that. Okay. You put then you put comma. I mean equal to. Just put delta y lah. Delta y. Yep. Can. Okay. Comma.
Delta.
Y. Okay. Comma. Not bracket. Okay. Then you put x max minus x minimum equal to delta x.
Okay. X max minus X minimum. X.
Okay, mom. Okay lah, okay.
Okay.
Yep, okay. Alright. So it means so next time when you refer, you understand okay why what you are doing here. So you can add here also.
So I need to press this.
No need. It's one time only.
Double click with.
Double click. Okay, just put convert integer to float. y equal to mx.
Yes.
Okay. Convert.
Convert.
Yes. Convert. Okay. Save. Okay. Now you download. So now you download a program enough because the parameter just now you already downloaded. Okay.
So the watching
Yes. Now can add the watch. Okay. Then you can add. Go to that. Okay. You monitor the program. Monitor. Go to online. Monitor. Can start monitoring all video game. Okay. Can you see now this one converted? Right. So it's an integer convert to floating. So floating will add a decimal point. Okay. So now when you add value at y max, y minimum, x max, x minimum, then you can get the result. Okay. So y minimum, y maximum is d0. Then you add d2. Then you add d6 and d8 enough. Okay, so the rest no need lah, right? Because you see d4 no need because this is the result. Correct. Then d10 also no need because that is the result of this value. So d12 others all no need, just need this. Okay. Now what is your y max? 100. Right.
yes.
Okay. You key 100 and the y. Yes.
Y max is 0.
Yes. 100. Enter. Okay. Next is the
D6.
d6.
D6 is the
4000, yeah.
4000. Yes.
Oh, that is d2. d2 is 0.
D2 is 0. Yes.
Enter.
D6 4000.
4000.
D8 is
Ah, okay. Can you see there's something wrong? Right.
yes.
No, no. Not because of
Behind is not changing yet. Floating.
yes. Some all the yes. The first one is okay. First one is correct. The yeah. From the second until the fourth. Okay. Okay, now you key in again. Key in again the value d0 and d6.
D0 is
100.
D6 is 4000.
Now can you get the value?
Yes, 29,
Yes.
so almost 100.
Almost lah. Why? Because your actual value is what? 3994. But we key in 4000.
Yes.
That's the reason. If you change this one to 3994,
Okay.
then you will get 100. Yeah, the maximum
3994.
dot. Almost dot. Yeah. No, no, no. You erase. Yeah. Okay. Enter. 3994.
So, question. If let's say the 6020 from the words and convert to floating, can
Here.
yeah.
No, cannot. You try and see. It won't give you value.
Need to convert.
Because this is just monitoring only. You go here. Can you see? But can you see here is still the same, right?
Yes.
Because this one is just a like a monitor only. It's like just like a HMI only. It means in the HMI can be any format, but PLC will follow the original format. So in the HMI, if you choose wrong format, you will get wrong value. If you choose correct format, you will get correct value. So that's why here is still same, but here I didn't get the value. Why? Because inside the PLC, this is integer, this is floating. But in the HMI, if I choose integer, I get the correct value. Right? If I choose floating, then I get a wrong value.
Something like separate.
Yeah, it's separated.
Two screen.
Yeah, it's because my PLC is just running on this. PLC don't care about this one.
Okay.
Got it? That's why I say no need to download. Right? Even just now you asked me, before you download, you want to key in all this, right? I said no need also. Because this one just like data reader. It's just a reader only.
Zero. Word. Yes. So maybe these are stupid Christian. From the analog, the words, the word is not a binary IO, right?
Yeah, it's not. I
That means
101010.
1010.
Yes.
That means from the 1010 convert
Decimal.
yeah, to
Decimal. Yes.
That's why it's a word.
Yes. Yes.
Okay, okay.
Correct.
Okay.
Ah.
It means the thing is first they capture the signal with the words binary, so convert to the decimal analog.
Yes.
So after that, okay.
Got it?
Then actually this one is solved question just now I asked. The reading is not tally because after change something, the maximum point already out.
Yes. Yes.
So if we get back that maximum point,
Yeah.
then the thing will
Yeah, we get the correct value like you said just now. It's 1 plus minus 1, right?
yes.
Maybe okay. There's another many situation. For example, now I choose 3994, right?
Yes.
Why 3994? Because my injector is
Yeah. The
394
maximum is
maximum lah.
okay.
Let's say I take out this later, I connect a new injector. Let's say. So what happened? The maximum will be 4000.
Yes.
But my output, what happened? We won't get 100. Will be like 99 or something.
Okay. Understand.
Okay, that's number one. Okay, just now you asked question the binary, right? Okay. Actually, that's how the PLC work. Even just now, we keep all these numbers, right? Okay, all these numbers are. We'll go into PLC and if you do some calculation inside the PLC, it will still be 101010. But we cannot see. Okay? But the word you can convert actually. You go to the right. The format. No, beside.
Decimal.
Yes. You change to binary. No, first one. The floating point can change. Yeah. Yeah, okay. Go to left.
Doing the same thing.
Yes.
Just easy for us to understand.
Yes, because inside the PLC, this is how it works. It's a byte 16 bit. Can you see, right? 4, 8, 12, 16 bit.
plus C, if let's say the thing is not start from the zero, so how should I?
Okay.
add?
First, because the plus C is y minimum minus mx minimum, right? Okay, so first you need to do this calculation first. As a multiply lah. So the m multiplied with x minimum, then you get the y minimum minus this, then you get the c. Okay, go to edit mode.
Okay.
Okay, SM400. Okay, first we find out this one. So M is what D multiply. So DE multiply space M is what D12. Yeah, D12 space X minimum is what? D8.
D8.
Yeah, D8. Okay. Then need to have a new result lah. Okay. So D16 cannot use. So D18.
D18.
Yep. Okay. Then you add another one below here. Control down. Okay, this one is because you already get this right.
X minimum.
MX
Yes.
calculate.
Yes.
Okay, now we want to calculate the offset. So Y minimum minus D18, you will get the C.
Yes.
Okay. So it's subtract, DE subtract.
Yes.
Maybe we put all the what address, I mean the name will be easier later. We put the comment.
Okay.
DE sub, okay, space. Y minimum is what? Y minimum is D2.
D2.
D2 minus D18 space the value put inside D20. Okay. Convert first. Okay. We put a name. I mean you enable the statement. No, okay. You put a statement first. Yeah. Yes. Okay. You double click here. Double click. You put calculate offset C. Okay. Okay. Now, because okay, now the 20 is C, yeah.
Yes.
Okay. But here now is M multiply X only. So the D16 is
Y.
no, it's not actually Y. The MX value.
Yes.
Correct.
Yes.
It's the MX value.
Yes.
If you plus C, then only you get the
D16 plus C.
yes. Okay. So what you do? You add in insert row.
Insert row.
You click on the number 9, yeah. Right click,
Insert.
edit, insert row. Insert row. Okay. Now here you control down. No. You can add below here, yes. Okay. This one is plus addition. DE add. Yeah.
Plus C is D20. Is it correct?
Yes.
And equal to D22.
Yes. Okay. Now you convert save. Yes.
Monitor.
Okay. So you key in the D0 value everything. Okay, now you get the value. Okay, so now no offset, right? Okay, see? Right, offset is 0, D20 is 0.
Yes.
Okay. Now, let's say we put offset like this. That is, let's say the range is negative 10 to 100, for example. So the graph will be like this, right? Right, it means so means if your analog value is 0, you must get negative 10. Now you put to 0, you will get 0.
Yes.
Right. So okay, so what you do, you put y minimum negative 10.
Oh, why?
Y minimum is which one? Your D2.
Okay.
Negative 10.
Negative 10. So 10 will become 0.
Okay. So now your offset is negative 10. Okay. Now you go back to 0. Okay, now you put to 5. Okay, what is the value? 54 lah. Earlier is 50, right? Because earlier is from 0 to 100.
Yes.
Now there's a extra 10. Okay. Now go to 0. What's the temperature now?
0.
No, negative 10. The temperature D22. D22 is your temperature. Correct.
Yes.
Okay. What you do? You click on the device. Yeah. Device comment. common device comment. Double click. Okay, you choose, you make it smaller. You select this one. Yeah. Okay, so easier. Yes. You choose D0. No, here. The device name. D0. Yeah, D0.
Okay.
Enter. Okay, you give all the values.
Yeah.
One by one, you put a name. So easier. Why the name? Because later on,
Confused.
no,
Yeah.
later when you refer,
Yeah,
they
very
understand.
confused. Write down is better.
Yes.
So it's
You can actually, you
one
can
text.
close this one, the navigation. Okay. Then this one you bring to this side. Bring some. Can do some more. Okay. Then this, the program can make it longer. Can make it longer. Okay. Down. Put it down. Yeah. Okay. Then one by one you can put in the name and everything. So easier. You want a coffee or Okay,
Yes, sir.
good. Any question here? One. Okay. Now,
Yes, sir. Is it all the sensor, all the reading must convert inversion to flow? Is it all?
if we want to do this calculation,
If not doing this, just straight away put in the result reading also can, right?
okay,
If,
but what happened? Okay, why we convert this value? Okay, that's the question, right? Why we need to do this conversion, right? Okay. Let's say I have a program that is, if let's say more than 75 degree, I want to on something or off something, so I need this value to convert, right? Okay, so we do that. Okay, you go to edit, go to ladder edit mode, right? Okay, go all the way down. Let's say we do a simple program now, okay? Normally open X0 output, put the output Y0. Okay, then you latch it down here. Yes. Y0. Okay, so let's say on output on. Okay.
Yes.
When the temperature reach certain value, I cut off the one. Okay, so to do that, we need to use a compare function, correct? Comparison. Okay, go down. Okay, so we do the comparison here. So to do a compare, I need to use the SM400. Just now we open. Okay. So, but depend lah, if the project got some different, if the project I have a different address, I can use that address to do the compare. So now I always want to compare, so I use SM.
Okay.
Now the comparison, okay, you key in A and D. Okay, go down, scroll down. Okay, you will have A and D. What they call? Because I want to compare. Because why? My temperature now is floating.
Yes.
So I need to use floating point compare. This compare all 32-bit.
No floating.
No floating. Okay. You take out the A and D. You just put the symbol greater than symbol.
Greater.
F
F.
space. Okay, your temperature is what value? D how much? D22. Okay, never mind. Just cancel it. Go and see. What is your go down D22. D22 is your temperature, right? Okay. Go down. Okay, now you compare. You put it here. Greater than F. D22 space. Okay, my set point is, let's say, 50. So remember, for timer we put K50, right?
Yes.
Because it's a constant number. So K means is used for words. For word we use K. For floating point we use E. For words we use K.
So it's E 50.
E50.
50 is 50 degree.
Yes, 50 degree. Okay? Wait. What is the command? You cancel. You click on the element. Okay, we find it here. You go up. Go all the way up. Okay, go down. Okay, comparison. Click on the comparison. comparison operation. Yeah. Just click once. Okay. Compare 16-bit, 16-bit. Look for compare floating. Okay. Go to wait, go down. Okay, wait. Look for floating point. Go down. No, I don't want this comparison. Here, this one also can compare, but I don't want this comparison here. Let me check what is the address. Oh, sorry. Must use E. E greater than. Okay, no. You try and see. Space.
50.
D22. Then E50. Yeah. It's okay. So E is for floating point compare. Okay. Then you put one output M0.
Oh,
Yeah, just put one output M0. Okay, so the M0 go up. Can use here. Normally close M0. Okay, compile, download. Okay, you key in the D0, all these values. D0 how much? Because every time you download this value will cut off. now you press start, the push button start, X0. Okay, output one, go up. This one go up a bit. The problem.
Close.
The last two line. Go down a little bit. Okay, there we go. Okay, now you reduce the value less than 50. Okay, now you press that. Okay, so when you start, okay, why the output can be any output lah. Okay, so when the temperature increase, okay, you increase the temperature, cut off. Can you see? Because when when this value is more than the 50, the output on. Correct. Then I use the memory to off my physical output. Okay. So this is why we do the scaling.
Scaling.
This conversion, right? This calculation we call scaling.
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 SCAL.
Oh,
scaling.
yes. We do this conversion. This conversion we call scaling. Okay. So why we need to do scaling actually? Because I want to do this comparison. So that is number one. Number two is I can show this D22 in my HMI. What is the temperature value? I cannot use the SD6020. I cannot use because SD6020 the value is 0 to 4000.
But yeah, but if I after
convert it becomes 0 to 100.
Yes, the reading.
So that is the reason I take this value and convert to this. Convert to temperature. Why? Then only I can do this. The SM400 E greater than D22 E50, then the M0, right?
Yes.
If I didn't convert, can I do this comparison or not? Can also. So what I have to do is I have to use the normal greater than. Normal greater than I must use this AND greater than SD6020. I want to compare 50, right? So 50 means what is the value? So let's say our graph is 0 to. So 50 means it's a 2000, right?
Yes.
Okay, so I have to use K2000. Then the M0. Okay. Why K2000? Because this is a word, right?
Yes.
So this one also must be word.
Words.
Okay. So this is float. So this one also I must use float, right?
Yes.
Okay. Because this is a float compact. Okay. This is the word of the 16-bit compact, right? Okay. So I can use this to cut off my motor. I can use this to cut off my motor. Both can. So like say for example, I have a temperature sensor, but I don't want to show the temperature value in my HMI. I just want to cut off the motor only, right? I don't need to do this calculation. I just can do this one. But what I have to do is I need to manually calculate if 50 degree means what is the value. I need to get this.
Yes, it is the question.
Yes. So I need to manually calculate.
Because 2000 is assumed.
2000 is the digital number. It's not a temperature, right? Because this one we call digital number, right? This is a temperature. This one got unique. This one no unique. So, but as a programmer, I can manually calculate to get the value. okay, and can do, no problem. But if I want to show in the HMI, I have to do the conversion. So to convert, I use the formula, but there's many ways we convert. This is the one way, first way. The one way is y equal to mx plus. This is the standard way, not standard way, like old style. Okay, there's many ways to convert. Okay, the main idea is if I get this value, I need to get this value. Okay, so that is number one. Number one is if I want to show in the HMI, I convert. If I don't want to show in the HMI, I don't need to convert, but I convert manually. I put like this.
If HMI, let's say I put K2000, HMI will come out the figure only, can be just figure, not the degree.
Can also, but who will understand?
Yeah, but
Can of course, can.
of course we would understand, but the thing still able to come out, right?
Can.
Okay.
Okay. Now like this one. Now my another question is, let's say I didn't show the in the HMI. Okay, I'm not showing in the HMI, so not using this. I'm using this. Okay. So because as a programmer, I know K200 means K2000 means 50 degree.
Yes.
Okay, let's say in the future, someone go and want to change to 55 degree. How? So he need to do manually calculate again, right? So he need to calculate again to get this value to change here, right?
Yes.
But if let's say I already done this one, the guy who want to change, or maybe you also in the future want to change, the 50 you just change to 55.
Understand.
So now you got the idea why we
Because
do
nobody understand what is K2000.
this. Yes. Even company owner or managers, they will understand. Only the programmer will understand.
Yes, no more in HMI someone want to change the settings, so easy for them.
Easy for them.
If K2000, what
2000. So let's say
yeah.
I want to do in the HMI, right? This one I can put D30.
Yes.
Then this D30 I can put in the HMI.
Yes.
I can go and change.
Yes.
Same things for here. I can put D30, but
I come up with a K.
so we don't know. So not K, just number enough.
Just a number there.
So but they don't know what number to do. So that is the thing.
Okay.
Okay, good.
Okay.
Okay. Now, just now your question is, do I need to convert this into floating?
Yes.
Or okay. If I want to do this calculation, yes. Because why? Because my M is this divide this.
Yes.
So obviously we know we get 0.0 something.
Yes.
So if I want to multiply with my analog must be in floating. So that is the reason we can.
Yeah.
Actually, they have another function called SCL. That is similar to this. We're using these startup prices, right? They have one function called SCL. The SCL of course something. Of course in front must be something right? So we use SM400 because I am always want to do conversion. Choose SCL. The first one must be your X value.
Okay.
Okay. Second one is they call the number of coordinate I want to use. Okay. Number of coordinate means how many points I want to use. Because like this scaling y equal to mx plus c only one line. Okay.
Yes.
If I'm using this SCL, I can do, if my graph can be like this, go up, then stay, go up, this also can. So I need to choose how many number of coordinate. 1, 2, 3, 4 like this. So I choose 4 coordinate. The last value is your Y. Means your output lah. Okay. So in this case, the X I can straight away can use this one. SD6020. The number of coordinate I need to choose like how many coordinate I want to use. Then Y can be any data register. So let's say the number of coordinate I put D inside D30. Then depend on D30, what is the value you put here, I need to follow. For example, okay. Let's say I want to use two numbers, two coordinate, means D31, D32, D33, D34. Okay, so this one will be these 2 point X and Y, and this one X and Y. Okay, then the result can be D35. Okay, D35 or any number lah. Sorry, but this D35 is depend on this. If I choose 3 coordinate, then I will have 6 numbers. So no, until 37. Because 31, 32, 33, 34, 35, 36 lah. The next number is 37. Okay? All these no floating, just 16-bit only. 16-bit, no need to use float.
All 16-bit.
All 16-bit.
All point is 16-bit.
All is okay. So this one is 16-bit, 16-bit, 16-bit.
Okay.
Then this one is 16-bit.
Okay.
So there's no floating in this case.
Okay.
So we try this. Then we understand. Okay? Okay? Now, what you go all the way down. Yeah. You go to edit mode.
SN400.
Yeah, SN400. Then you use SCL.
Yes. Yeah.
Yes.
Space.
Space SD6020, because SCL must put 3 data. It's your analog, right?
Yes.
Okay. Space no 60. Your 6 is missing.
6020. Okay. And
D30, yeah, because they only use until D32, right? Okay. Enter.
Enter.
Enter. No, sorry. Next. Space.
Space.
Okay. So we assume we want to use 2 coordinate only. So D30 is to choose how many coordinate.
Yes.
Then if let's say choose 2 coordinate, then must use 4. So 30, 31, 32, 33, 34. So next number we can use is 35. D35.
Not really understand because 2 coordinate is why is not 30, D30 and D31?
Okay. Because this one we put D30, right?
Yes.
Okay. Mean D30, from there it's continue.
Okay.
Continue lah. Okay.
Yeah.
So the continue is the rest of the data is depend on what is the value you want to key in here. Let's say you put 2 coordinate, it means this is the 1 coordinate, this is the second coordinate. I mean not 2 coordinate, sorry, 2 points.
Okay.
Number of points, actually number of points.
Okay.
So how many points are we going to use? 2 points, right? Okay. Means this point and this point.
Okay.
So this point will have 2 values. One is the X minimum, Y minimum.
Yes.
Then this point will have 2. X maximum, Y maximum. So X minimum, Y minimum, X maximum,
Let's say is number of coordinate is 3, that means I need to 3 set.
Yes, correct.
Okay. So D30, then
We just allocate 5 data there, then next one is D35.
how should I key here after D30?
This one no need to key in. We just key in this enough.
D30 equal to 2.
No. D30 enough. Next, D35. So later we see how to key into everything.
Oh, okay.
Okay. So, okay, now that's not finished. You download, convert, download. Then we can use the watch table to key in the data first. So this one will be first one will be the x coordinate. So means x number 1, x number y1, x2, y2. Monitor. Okay. Now you see D35 nothing, right?
Nothing.
Okay, because there's no nothing. Okay, what you do here, you key in D30, 31, 32, 33, 34. Okay. Now, at D30, you key in how many points you want to use. 2 points, okay, 2, enter. Okay, so if I want to use 2 points means 31, 32, 33, 34, okay. Okay, 31 will be my x point 1, right? So this is the point 1. X is 0, right?
Yes.
And the y point 1 also 0, right?
Yes.
Okay, we leave it. So x2 means D33 is 4000.
Oh, 4,000.
Yeah.
X.
X.
Yes.
4000. D33. Yes. Okay. Then this one is 100. Okay. What is your temperature now? Yes. Because it's a 5 volt.
Yes. Yeah. Okay. So the maximum, the minimum is two points.
Yes, minimum of course.
Cannot be one, right?
Cannot be one. Maximum can go up to, not sure, but the manual will show 10 points also. Okay.
If let's say if 3 point, if let's say I put in 3 point, normally the
35 carriers.
I mean the 50 will be, the half will be
Yeah.
another 1 point, right?
Yes.
Depends on how many
Points you want to use? All that.
This one specially for those, it's not direct
Direct,
line,
yes.
It's not the linear.
Linear one, there's like a curve.
So every range you need to
Yes.
set for that.
Yes. Got it? So means you have 2 options. So if I want to use D35, I just use the A and D, D35. Let's say for example so let's say I already converted using this one, right?
Yes.
Then I can just use A and D, D35, compare with K50 value, then M0. So can. Because now the D35 is my temperature value, but it is 16-bit
What?
word. So
K50 now is become
because 50 degree.
become degree.
Yeah.
Normally before we learn is K50 is a second.
Yeah, because that one is why? Because that one, the number we use for timer.
TO.
Ah.
The
So
command
this,
is T.
this one is like a constant number only, just a number. So it depends where we are using the number.
But now this one is different with the, if let's say if we put 10 seconds, that means 100.
Yes.
But this 50 is 50, not 500.
No. Only for timer is different.
Okay.
Ah.
Then the ends here is a compare command,
Which one?
AND,
It's a compare command.
or not the or and.
Actually that one also they call and symbol, and
Yeah.
so that. But this one, because I didn't put and only, I and a
Or
symbol.
with the sign.
The sign
so
here.
Become compare.
Yes.
Okay.
Mm.
So the sign less than we still
Less
the
than
same, right?
Yes. Got six data. So more than equal. So need to add equal also.
Circle line.
Equal. Then less than equal. Then another one is
Equal.
equal. Then another one is not equal.
Oh yes.
You can take picture of this one.
Yes.
Interesting, huh?
Very interesting.
Yeah. Actually, you very good. You buy one PLC this right. You play around, you know.
More practice make perfect.
Yes, of course. Of course, I need to practice. Okay. And we learn, we share each other knowledge. Just now the guy come also, because he got a project, he working in Singapore. Last time in 2019, then 2020, he come and learn Siemens. Then after that, I think after 7 months something, he come and learn Mitsubishi. Then in 2020 during COVID. Then after that he working in China. So like 2 years back he's working in Singapore now currently. So he got a project. So that day he messaged me, asked me how to convert this on. And I said I also never done before. So then he said whether I will be in office on Sunday or not. And I said because at that time I was in Singapore. And I told yes, I will be Sunday, I have a training. So lunchtime you can come. Just now we come and discuss. Because what happened in Siemens HMI, so I just share you knowledge. Siemens HMI, they have a screen, all the screen, everything. Now you want to convert that screen into SCADA, Siemens SCADA. SCADA software. SCADA is computer based, PC based. Okay.
Yes.
So now what happened? The SCADA is an older software. So this one is a newer software. So there's no option like
Convert.
you just like direct convert. You need to redo again. So when we do, because SCADA also going to control the same machine. Okay, so when you want to redo, a lot of work. So I just tried Google, because I never done before. I tried Google and see cannot. Then he also, before he come, he also used Google and cannot. Then, but he told me that if he able to use the tag means your names like always on the channel one and this all these names if he able to use that, for him is okay already. Okay. So what I do, I told him so how to do. So just try Google, try to go YouTube and see got some one video. Then together I see with him and I show him okay. So you export the data from the HMI data, you export the tagging everything, your computer. Then from the computer you import to your SCADA software. So just now you import to it. So but the problem is you need to redesign again. The
picture not follow. Just the
Picture
program only.
Picture cannot follow. But the data from this one can follow. So data I convert because you see he can do the picture, but data can do, but one by one will take time because the data is just now you see is around 2000 data. One by one cannot. Then he say then once he can convert ready because just now he try cannot. Then what happened? I just go to YouTube and see. There's one column you need to tick. Then only you can take data. Then I show him. Then tick. Then okay. Then he happy ready. Then he said, okay, okay, now I'm okay. But he said, no choice, I need to redo. Because he doing, their company is doing water treatment in Singapore also. Water treatment, but they are the commissioning team, the main company is in Germany. They doing project. So whenever in the company they do projects, once they finish the mechanical part and the electrical part, these guys go and do the commissioning. Because the program was already done from Germany, so this guy go and download, do the communication setting, everything. Then during commissioning, they need to increase and decrease like this lah. The X value, Y value, because programmer, when the programmer will follow this number. But in actual, when you connect the sensor, everything, you won't get 4,000 exactly. You get like 3,998 something. So these guys are going to do changes.
What we do.
Like just similar thing what we do.
And the SCADA also need to attend another course, right?
Then this course we have SCADA, later I show you SCADA. Okay, can? Any question?
No.
No, So, but not every time I want to key in like this, correct or not? Because the PLC, right, you stop and run.
PLC stop
No need to reset, just stop and run back.
and run back.
You see, all your value go off already.
Oh,
Okay? Okay. How am I going to key in the values? Okay. You go up. Go all the way up.
this.
Go all the way up, Okay. So this Y max, Y minimum, I can key in here itself. Okay, I will show you. You go offline. Any. Yeah. Because I always use that name. Because like Siemens, Omron, they use that name. That's why.
Right.
Okay. I don't want to disturb this program. You save first. Save. No.
Sorry.
Okay. You save as another version. Go to project.
So, project.
Save as. Okay. Analog version 2, V2. Okay. Save. So original we don't touch. Okay. Now. So this Y max, Y minimum, X max, X minimum, right? So we key in here, correct?
Yes.
So we cannot key in every time. So how like permanently we do that? So this is where we use the constant numbers. Okay. Constant number means this K and E. Okay. If it is word, we use K.
Yes.
If it is float, we use E. Okay. Now, Y max, we double click here. I mean the double click. The D sub, double click the escape. Escape. Press escape. Okay. You double click the D sub. Okay. So D0, you put it, Y max is what?
Maximum.
100, right?
100, right.
Okay. You key in 100. So the D0 you take out. D0 you take out. Okay.
300.
100. Okay. What?
300.
No. E.
Floating.
Yes. E100. Okay. So the D2 you take out. You put E0. Okay. Yes. So now no more D0 and D2. So no need to key in every time. Straight away there value. So we do for this also. X max, X minimum. You click on the sub, yes.
This is X max is
4,000. Yes. E4000.
Yes.
Okay. Then D8 is E0.
X zero.
E0. E0. Okay. Alright. You convert save first. Okay. for this because I can change here, correct?
Yes.
Okay, go down. Okay, this D30, 31, 32, 33, 34. How am I going to change? Where I want to do the value, right? Where can I, key in the value? And just now it's in the calculation, right?
Yes.
But this one how to use, right? Okay. This is where I use the move function. Move means from one area to one area. Okay. So how to move? The move also I put below here lah. You put here control down. Okay. First you put move MOV space. Okay. So I want to move value to the D30, right?
Yes.
So I want to use how many points? 2 points.
2 points.
And D30 is integer. Is a word, right? So you put K2
K2.
space D30.
D30.
Yes, okay. So it means it's always on, right? So whenever you turn on the PLC, the value 2 will go into D30. So you don't need to key in like this. Okay, can? Okay, you take another one. Control down, move, space. So this one for D31 is 0, right? Value 0.
Yes.
So K0,
K0.
K0,
K0.
D31.
31.
Yes. So you do the same thing for 32, 33, 34. So 33 is X maximum.
K0 also.
No.
Uh,
32.
Oh,
Yeah,
yeah,
K0,
K0.
K0, sorry.
D32.
Yes.
K.
Is a yes.
D33. K100. D34.
Okay. Convert. Save, download. Right to PLC. Programming, okay. Yes. Okay, done. Close. Yes. Okay, monitor. You see, now at D30 already have the value. You see here, you don't need to key in values anymore. Right? Because already move. Okay? You go up, you go to the this D22 also already got the value.
Yes.
Because why? You go up. Because this one got value already. Earlier we manually key in.
Yes.
So
Yeah, I can key in the value, then the thing will shift move to the washing, right?
yeah,
Can I key from washing the
Cannot.
the one way?
one because it's already moved. You cannot cut unless you cut off the move.
I'll take away the move.
Yes, not take away the move. You go down. This one. You go up. Okay. Go up. This one. Unless it's not always on. Unless I put some interlock here. Means when I turn on, it's moved.
Yes.
When I turn off, then in the HMI or in the wash table I can change.
When we turn off, then can be changed.
Yes.
But what I change, but change means change from the program side or change from the watching side?
Watch side.
Watch side.
Watch or the HMI.
But once I change from the watch side and on back, the data automatically will go in.
What happened if I now let's say like I cut off,
Okay.
then I change here, right?
Yes.
So what happened? Your D30, all this data lah.
Yes.
All this data will be follow your wash table.
Oh.
Follow your wash table. Okay. Or let's say your HMI lah. Okay. But the moment I on back his, it will follow the move value.
And once I on, the thing will back to this.
Yes.
Oh.
So it will, of course, it will change your watch value also lah.
Okay.
Because you are watching this number only, but
So if that temporary want to troubleshooting whatever, you off this, but watching side you still able to
yes.
do something.
Yes.
But once on back, watching side will follow back the original.
Yes, can
Okay.
do. So instead of using this, maybe you create one like auto manual switch. When it's auto, all the value auto. When you put manual, you can do the changes and settings and everything.
So I also can create once on will follow this reading, one off will also follow the
Another reading also can.
Uh,
You can create another set of move. So when I on, I follow this value. When I off, I follow the other value. That is the move function. Got it?
okay. Move just transfer just bring the value to other place.
Yes. So got two data, so it will move the data 1 to data
So if let's say I want to take some reading from the move, from the D.
2. Yeah. Because our normally if any PLC have analog like this, sure they will use a lot of move function. Because they cannot every time go and key in, run. Because the moment PLC stop and run, the value will go off. So that's why we use the move functions. Okay, good.
Okay.
Any question? Actually, for me, I'm really happy to teach you because you're not just following, you just try to understand the concept. Sometimes I have participants and they just try to just follow me only. So they don't understand also, they don't ask questions. So for me okay, but for me I just like for them only rookie, because they cannot understand me, rookie they pay money or even the company pay money also rookie. So that's why I tell them, okay, you ask question. Anything small thing not understand, never mind. Let's say you ask a question. Let's say I don't know what is that. What I do? I'll go to Google and see, try to understand first. What is that? Okay, then try to teach me. That's what I do. Of course, you cannot know everything, right? So sometimes if something, sometimes you ask something. Okay, let's say I don't know. Maybe I never come across. What I do? Okay, never mind. I go to Google. I take note. Go to Google and search what is that. Okay, this. Try to understand first, and then I teach you. Okay. Any question? So
Okay. That day at company, I try to read some PLC.
Okay.
I try to understand. Sometimes also not so good. I see there's a lot of paper. Sometimes let's say I'm looking for a M10. Let's say M10. I know the M10 is control something, but how for me to search the whole program, where is the location
Of
with
M10.
all the M10.
Yeah, very easy.
Should have this function of
Yeah, of course. Okay. Now we talk about, because we are not repeating anything here, right?
yeah, that's correct.
Maybe the Y0 can, or the M0 lah.
Mm.
Okay, so how can you see find and replace? Right, you click that. Can you see find device?
Find device. Just keep
M10. Sorry, M0.
Y0.
M0.
M0.
Yes. Find all find. Okay, so it shows that I use at two places. Maybe the watch table can close. The watch can close. So I'm using at two places. Okay, you click the first one. No, here. Double click. It will bring you here. Click the second one. It will bring you here.
Because I'm not with the system, just a paper, so I need to search for it. No choice. No choice.
Very difficult. Another thing, you don't try to understand the company program. Very difficult because we don't know how they write the program. We don't know the flow. Maybe even you know the flow. We don't know which memory they use. The best way to understand your company program is every time you have a problem, you of course you will do the troubleshooting. So how you will do the troubleshooting? From the output. Right? Let's say your Y is not working. What do you do first? You will search the Y first.
Yes.
You will see the Y. Okay, like this also lah. Let's say example lah. Now you want to understand. Let's say you know how the program works. You increase your this one. Okay, just leave it lah. You press start, not working.
Oh, okay.
Okay. Now you find Y0. But you know your motto is Y0, right?
Yes.
Okay, you search Y0. All fine. Okay, got two places. Okay, you click here. This one. Okay.
Yes.
So you straight away go to the output.
Yes.
So the second one I don't need. I don't care about that. This one, right?
Yes.
Okay, now I come to here already. Okay. Here it shows that there is an input, there is a memory. Okay.
Yes.
So you press the input. You press the input. Okay. So the input is working, but the problem is with the memory, right?
Yes.
Okay. You click the memory. Right click. Actually, I can use this one. Cross reference. Okay. So you bring it up. No, here. This one, bring it up. So in the cross reference, it will show this file means it just show me where I'm using the file, right? Okay. But the cross reference, it will show me where I use and how I use. Whether it's a normally open, normally close, or output.
Yes.
Okay. Now, so the M0 does not normally close, right? It's because someone is on the M0. Can you see output?
Yeah.
Okay, you double click. Okay, now this one, right? Okay. Why this one is on? Because, so we know E is constant number, 50 degree.
Yes.
And let's say I don't know what is 50, right?
Okay.
Let's say I don't care what is 50, but it's 50 and from the D22, correct?
Yes.
Okay, you click D22, no, just close, right click, cross reference. Okay, D22 I use for two places. Okay, you double click the second one, is this one, okay, double click the first one. Okay, so D22 is from calculation of D16 and D22, right? So D20 nothing.
Yes.
D16 got some value, okay?
Yes.
You right click D16?
Looking for D16.
Yes.
Fine.
So D16 is the result of M and X.
Yes.
So what I do, I need to check the M and X lah.
Yes.
So for example, we check the X. Okay, close.
Check the X. Fine.
Okay, it's from where? It's a integer to float conversion. So this one is from where? SD something, right?
Yes.
So it's a channel 1 digital input. So
You can step by step.
so now when you do a
trace.
when you do the comparison, so now you know, okay, first output not on because of memory. Why memory? I do comparison. I know 50, but I don't know what is 50. Then when I check, I come to this address. When I open my wiring diagram, I know, oh, this is a temperature. So now I know, because of the temperature, so the 50 is means it's a 50 degree. So now you know the flow already.
Yes.
But if you read from the top, you cannot understand. That's what I say. If whenever you have problem or even you want have a time want to read, you go one output by one output. So let's say motor. You have a motor, want to understand how the motor works. Troubleshoot. Go back because of course it's a simple program, just straightforward. Your system sometimes will have so many interlocks. So it means when I start, okay, this sensor must be on, this sensor must be on, this temperature must be low, this one, all this condition, then only the motor.
Yes.
So if you want to read from A to Z, cannot. You need to read from Z to A. You need to check. So reverse engineering. So when you do reverse engineering, okay. So you will have, let's say, got 4 conditions. So when you check, okay, first, sensor must be on, then temperature must be below 50, then the must be in auto mode. Another one is the inlet valve must be off or something like that. So when you do this one for one motor, you now get ready the flow. So if the motor want to run, okay, sensor must be on, inlet valve must be off, temperature must be 0, less than 50, then it's in auto mode.
From bottom. to
Yes.
top. Okay.
Got it? That's how we do. So this is what they call cross reference. All these are the tools we use for troubleshooting. Okay, good.
Yeah.
Any question?
No.
No, okay. Yeah, that's nice. So whatever you've done, you save,
Yes.
close the file you close first. Save. Then tomorrow we continue. Tomorrow we connect the motor. Tomorrow we learn analog output lah. Analog output also same thing, same calculation only. Just the y and x will be different. So your x-axis is the value you set on. The y will be your analog output. So when you change this one, of course this one also change already. The mx also change already. You can do small project. Let's say you already have the HMI.
Because I also looking for the servo motor.
HMI you already received on that.
They're on the way. I
On the
think
way.
Maybe hopefully on Monday.
Monday lah.
Don't know whether can make it. or not.
No, what I want is if you already have that,
Yes.
you can bring,
Yes.
so I can see.
Yeah.
Okay, I also want to buy. That's
Yeah.
why. Maybe you can share me the link.
Can.
So because currently I have one, so I can get another one lah for training. Because I remember last time I buy the one is expensive, 1,000 plus.
Maybe the thing is just is the latest that time.
Latest one, yeah, maybe. Because this wind, you mean this model right? Windtech, right?
Windtech.
Okay. There's a good thing. You see, mine is not Windtech. Check and see. Windview, right? It's not Windtech. Okay. So yours also maybe is Windtech or Windview?
Windview. I follow this.
Yes. Okay.
It's Windview.
Windview is made in China. Windtech is made in Taiwan.
What is
But both all same only. Software, everything is same.
now the price is standard. Or the difference is whether they are including the postage.
Yeah. Postage
It's
and
a standard
also
price only.
standard price. Then another one is the models also are different models, right? Why they have different models? Because this is 7-inch. 7-inch is starting with MT07. You see it is at the back?
Mine is 80.
It's 807. 7 means 7 inch.
Oh,
If 810 means 10 inch. And this is a 10
yes,
inch.
yes.
You can see 810. It's a 10 inch. Okay. So they have 8101, 8010, 13, right? You know what is the difference? Some come with the Wi-Fi, built-in Wi-Fi. Some without Wi-Fi. With the Wi-Fi, expensive. Without Wi-Fi, it's just normal price only. Means, but still can use internet. With Wi-Fi, means you can connect, do some setting, connect to your house Wi-Fi. So from anywhere you can just log into here. If no Wi-Fi, still can use. The thing is,
Internet.
internet directly can use.
Yes,
I need to connect.
it's different.
Yes, that's the thing. That's the difference. Because the day I buy this one for a project. I haven't fixed yet. This one, when I buy, they give me another quotation, 3,800 something. That one with the Wi-Fi. Then this one is the 2,000 something. Then I say, I don't need Wi-Fi. Because the project is just very simple project. It's just what? You want to monitor the temperature, pressure. You want to see the graph. That's all. Oh yeah, no, it's fine.
Just leave it here.
Can. You want to leave it here? Can. Because the next 3 days, we're already working.
Hopefully the HMI.
I mean, it's not easy, no problem. But later, if you have time, you just share me the link.
Okay.
I see the link, and because we also want to buy few parts this year. Then we just ordered Siemens new model. Then maybe next month I need to order one like this, one driver like this for LMW. Because there's one guy request from Petronas Chemical. So he wanted to learn Siemens and also LMW. I have Siemens one, I have LMW, I don't have. Rain.
This one very fast. I think 5 days time.
Oh.
I use the flight.
But still okay lah, cheaper. But you need to buy, if you want, you take the picture of the cable, you
Yeah.
buy one. Or you can use the internet also. Tomorrow we test the internet, it's not a topic to test. Because if internet can use,
I think I want to buy another one for my sister because want to run the
servo motor. Okay. But I'm not, yeah, sure they have. Empty, you look for
yeah, they have.
Yeah.
I thought relay can run, can last longer on relay.
But relay can last longer, that's one.
Yes.
Relay can last longer, not easily, the output won't easily burn.
Yeah, but compare the transistor.
Yes.
Okay, see you tomorrow.
Okay, see you tomorrow.
Yeah. See you tomorrow.
Alright, session end for day 3. Thank you very much.